training your own ASR models. Okay, so what we want essentially is that you should be able to get started with your journey in training models for Indic languages, and we will take 40 hours of data from IIT Madras challenge. That was the first challenge on IITM Hindi competition. So let me open that link. So this was the challenge by IIT Madras. We didn't participated in this challenge because we didn't know about this challenge at that point of time. Didn't know about this challenge. So, but we have the data. The train set 40 hours, the dev set 5 hours, and the evaluation set of 5 hours as well. So, which is a total of 50 hours of data. So we'll get started with the model training part today and probably tomorrow as well, because model training takes a bit of time on the GPU. Before that, there are some technical terms that you may encounter, and you will scratch your head, maybe like, what is this going on and all, right? So just to give you an idea, so we are using deep learning. So deep learning is a technology. Okay, so it's a tech. And we are using PyTorch as a language. So PyTorch is a language which is used to build deep learning models. Okay, so this is a language which is created by Facebook. Okay, a language or framework, you can say anything. I prefer to say it as a language. Even Python is a language, but PyTorch is not a language. So I just tend to say it a library. Okay. So PyTorch is a library which is created by Facebook, which is used to do deep learning. Okay. And then FairSec is a toolkit which is also created by Facebook, which is built on top of PyTorch. Okay. So what is the difference between FairSec and PyTorch? So the definition of FairSec is Facebook AI research in sequence models. Okay. So since we are dealing with sequence models here, I mean sequence in the sense speech is a sequence problem. So they have created a separate toolkit which is only especially for the sequence task. So this is a toolkit by Facebook, FairSec. So it's a sequence modeling toolkit that allows researchers and developers to train custom models for translation, summarization, language modeling, and other tasks. So apart from speech, you can train your models, translation models, you can have summarization models and language models as well. But what we are going to focus on, only speech. So what our team did here at Vakyansh is, so Vakyansh is a framework that is built on top of FairSec. Okay, so to provide you more abstraction. So basically we want that if you want to train your model, it shouldn't be very hard for you to get started, and it shouldn't be very hard for you to train and get your models and run inference and all. So we have created a platform in which you can come. So this is the experimentation platform. I'll pass on the link in the chat window. So this is the experimentation platform that we have built on top of FairSec to provide you abstraction so that you can get started with training and inferencing your models quickly. Any questions up till now? Okay. So deep learning is a technology, PyTorch is a library, FairSec is a toolkit, and Vakyansh is a platform where you can come train your models, infer, which is built on top of FairSec. Okay, I know it's, I mean, for a new person, it sounds a little bit confusing, but The point here is to provide you the maximum level of abstraction from the, it, it shouldn't be the case that you should be going and fixing the code. Okay, so that part is ours. What we want to give you as an experience is usability experience, that you can use it very easily, so that you can train, you can focus on the application part more. Okay, so how can you train and use those models in certain use cases, applications, apps, or anything else. Okay, so before we get into the model training, let me just explain you the a little bit features of the platform itself. Actually, the folder names are quite explanatory, but again, I will explain all the things that I think are required for you to understand how to use this thing.
Arvind, can you just increase the web page size if
Yeah,
possible?
sure, sure. Okay.
Yeah, it is visible. Yeah.
Yes. Okay. So you see that there are a couple of folders in here, and you will be interacting with almost all these folders, and these folders have a particular purpose here. And I mean, if you go through the documentation, everything is written in the documentation, but I'll give you a little bit of context. Okay, so the first folder here is checkpoints. So checkpoints, as the name suggests, is a folder that will save your checkpoints. So either you will be doing fine tuning, or either you will be doing pre-training. Okay, so pre-training will contain the checkpoint for pre-training, and fine tuning would contain the checkpoint for fine tuning. Okay, so the checkpoint size is quite large, which is greater than 1 GB. So that is why we cannot push that to Git. Okay, and that is why these folders are empty. But the folder structure is so that when you start your training, all your fine-tuning checkpoints will be in the fine-tuning folder. All your pre-training checkpoints will be in the pre-training folder. Okay, the next point here is config. Now, different models have different config. Like a pre-training model has a different config than a fine-tuned model. So that is why there are different folders here as well. So when you open pre-training, you'll have a config here, which you can see that there are certain parameters in the config, like at what interval do you want to save your checkpoint? Do you want to do a fixed precision 16-bit training? And I mean, in data, I mean, we'll go through this config when we'll start the training one by. I'll explain you each and every parameter. But right now, the point here is to understand that this is the pre-training config. Okay, the fine-tuning config also looks similar to it, but it has some extra parameters apart from pre-training model. And there are different configs for different amount of data. Like for 10 hours of data, there is a different config. For 100 hours of data, there is a different config. For maybe if you have 1,000 hours of data, then there is a different config. Okay, so different config have different hyperparameters. I will also explain you which hyperparameters do we tune, and what is the difference between different amount of hours. Okay, so we will cover this when we'll start training, and then I can explain you maybe one by one what is the config and all. But the point here is just to understand that different amount of data may have different config. Okay, and the wave to vec comes in 3 sizes. Okay, if you go to FairSec toolkit, which is the official toolkit, examples and wave to vec. So you'll check here, the wave to vec comes in 3 sizes. One is base, one is large, and there is another model called XLSR, which is also based on large. So essentially, what the difference between base and large is the number of layers. Okay, so base has only 95 million parameters to tune. Large has 338 million parameters, which is like close to, I mean, 3.2 times that of base. Okay, so here we will be training a model on the base architecture, and whatever models that we have also open sourced as a part of trained models, they are also based on base architecture, because large actually consumes a lot of GPU power. You need to have a minimum of 64 GPUs to start the training. Okay, so a large model may not get executed on every machine, and its model size is also huge. So the base model size is only 1 GB, the large model size is 3.5 GB. Okay, so we will be covering only the base architecture. Okay, and that is why the config name is base underscore 100h. Similarly, if you have some configuration for large, it would be large underscore 100h, where 100h is the amount of training data that you have. Okay, now checkpoints is done, config is done, then comes the data part. Okay, so data itself for pre-training is different, for fine-tuning is different. As in pre-training, we only have the audio data. In fine-tuning, we have the audio plus text data. Okay, and how this data would be represented as a part of wave to wake, we'll cover that in a moment. But the point here is just that this folder will save the TSP files, which will contain the paths to the data location in your drive. Then this would contain a TSP, which would contain the full path of those text files and full path of those wave files. Okay, so LM I'm skipping for now. So logs is something where you can see the training logs. Again, for logs, pre-training, for pre-training there will be separate logs. For fine-tuning, there will be separate logs. So whenever the training gets started, you can head over to the logs folder, and whatever task that you are doing, which in our case is fine-tuning, we'll start with the fine-tuning, and inside the fine-tuning folder, you will be able to see the logs for the training. Okay, so these logs will also get uploaded to WAN-DB website, which Neil might have shown you yesterday, and you can view the logs from there as well. But if you want to view the logs from machine, then the logs path is there. So notebooks, if you have some experiments that you want to do, then you can save your notebooks here. We actually do not work with Jupyter notebooks. We work with Python scripts in this, so you'll find a very less number of notebooks in this folder. Then we have a folder called results. In results, whatever inference that you will do on the data set, that results would be stored in this result folder. Okay, so suppose if you are inferencing on the dev set of the IITM challenge that I just showed you, then you will have your results in the result folder. Okay, so see, this is an architecture, this is an enterprise architecture of segregating things. Okay, so you cannot have all the things at once. So as we are giving a platform, so that is why it's very required for us to actually segregate different things in different folders. So I'm just giving you the gist of what will you find in different folders. Okay, so then comes a very important folder, which is scripts. Okay, so most of the time we will be working with this folder, because if I have to do retraining or fine-tuning, all I have to do is come to scripts, come to fine-tuning, and just execute bash start fine-tuning. That's it. And the fine-tuning would get started in the logs folder. The logs will get logged. In the checkpoint folder, the checkpoints will start saving, and all of these things. So there are a couple of parameters that you need to set before starting the fine-tuning, which we'll discuss in maybe next 20 or 30 minutes or so. But this contains only the bash files. This folder only contains the bash files, whether it's pre-training, whether it's inference, or it can be anything. So these bash files are your abstraction modules. Like if you are driving a car, suppose you are driving a car, you are given a steering wheel and you are given a gear, right? So if you want to change gear, you know that you have to push it. And if you want to turn the car, you know that you have to rotate the steering wheel. So this is your steering wheel and gearbox. Okay, so this is the place where you will just provide some inputs, and all of the things in the backend would start automatically. Okay. So scripts is the folder which contain the batch scripts, and then I leaving test and timeline. These are not folders that are useful for us at the moment. Then comes the utils folder. So all the Python files that get executed from the batch scripts are kept in this folder. Okay, so all the Python files that you run, I mean, I can even show you. So in scripts, if you start fine tuning, so let's fine tuning. If you open the start fine tuning, then you will see that we are calling, okay, it's not here, but I'll open like inference and maybe infer. When you start inferencing, so it goes to utils folder, and within inference it executes the infer.py script. Okay, and all the parameters it takes from here from the batch script. Okay, so from batch script you just need to pass the parameters on which you want to run the inference. It will call infer.py at the backend on its own. Okay, so again, I mean, if you turn the steering wheel, you don't know how the tires are turning. Okay, you don't know how the combustion is happening in the engine. That is always hidden from you, right? So you will only check the engine when there is some heating problem or something in the car goes wrong or something goes down, right? So similarly, we'll only check the utils folder when there is a need of emergency or there is something that is purely broken off. We will only interact with the script folders as of now. Okay. Any questions till now? Okay. Am I audible? I mean, people are listening or yeah.
Yes,
Yeah,
sir.
yeah,
Yes.
you're audible, Arvind.
Okay.
Arvind,
Yeah.
also, if you have any top level block diagram wherein we'll have a overall picture of whatever that's been developed, is
Mhm.
there one such document or something?
Uh, I mean, documentation in terms of this platform or
Yeah,
the
this particular platform, whatever you people have developed, right? Is there a broad level block diagram?
no, not we don't have a diagram, but I mean, because this is kind of a self-explanatory thing, right?
Yeah, yeah,
So
fine,
yes,
fine.
we have a directory structure here. If you
Okay,
want, you can check here, but we don't have a block diagram for the same.
okay, no issues, no issues.
Okay. So now the first task here is we need to set up a FairSec. Okay. So we need to set up the FairSec toolkit on our machines that we are using so that we can use this experimentation platform and we can get started with the model training process. Okay. So okay, so I'll share my screen. So Priyanshi is also in the call. She will be putting out the commands that I will be executing on the terminal so that you can also do it. What I recommend is that maybe one person from each team can get started and maybe start executing line by line with me, okay, because that would be really helpful. Because if in the installation process it's a little bit tricky, okay, so once the installation is done then things are very smooth, but during the installation process I would advise that one particular member from a particular team should start doing it with me, okay. So I'll do everything from scratch. I have nothing set up. I will tell you how to set this up, how to go about these things. And also, if you open the timeline tab, uh, there is a data preparation MD. I mean, which
Arvind, just for the use of other groups, Jagbandhu, if you can specify who will execute in each of the group, That will be helpful because else everyone will start working on it.
Tomorrow I will send the group list, means group member list.
Sorry, yesterday Lalaram have shared. Maybe
correct.
Lalaram, you can share it again.
I'm
That same
sharing
list.
it.
Yeah,
I'm sharing it.
please.
Yes.
Yes. So maybe we can share on. I just want a confirmation that once you're logged into the machine, you are able to see a base with your name, which means your environment is activated. Conda is initialized. If people can just share this confirmation, then we can get started with the installation process.
Yeah, group information is in the chat. Please check.
Yeah, Arvind, I think the participants will switch on the instances also. So
Yeah. Yeah, we'll wait for 5 minutes, let them switch on,
yeah.
and then we'll start the installation.
Jagabandu, just Jagabandu, hello.
Yes, sir. I already have started the instances. Maybe.
Okay,
Yeah.
maybe you can assign to other person. I'll assist because if they can do it, will be better. I think from group 4, you assign me actually.
Oh,
So
sorry.
so it will be better for them. Yeah, I'll be there. So
Okay, sir. Okay, sir.
Jagbantu, yesterday we had issue for group 11, right? We are not able to connect to.
It's up now, no? You can try to connect now.
Yeah, that's what I was not able to connect. So
Now also?
yeah.
Okay.
Yesterday, group 3 was also not working. Jaga?
No, group 3 is working, no? I checked yesterday.
Okay.
No, sir.
Jagbantu, can you check once for 11 whether it's working for you?
Yeah, I will check.
So from group 4, Sajal can do.
yes, I'll be there. I'll assist, sir. So
Yeah. Okay. Yeah, I'm able to log into group 11 actually.
Okay.
Yeah,
But,
I think it is fixed.
okay.
Yeah, you can also try and let us know if it is.
Yeah.
Group 11 GPU.
Yeah, I'm able to log in, Jagapan. Yeah.
Yes, now I'm able to access. Thanks.
Likewise, all other groups, if they can at least tell if they are able to log in.
I'm able to log in group number 3.
Okay, you can mute your mic. There's so much disturbance. Yeah, Ayush, you are able to log in, group 1?
Yes, group 1, perfect.
Group 2?
G1?
Group 2, G1?
I'm able to log in, sir. Yes, sir.
3, Salam has done. 4, Sajal?
Yes, sir, in GPU?
Yeah.
Yes, I am
Okay.
logging.
Group 5? Chingamukim, someone.
No, sir, I'm not doing.
You are not doing?
No, Chingwon Kim. Yeah. So she was unable to, right?
Group 6. Okay, group 5. If she not, then anyone
Yeah,
else
I'm
can do. No?
finding someone else.
Group 6, Tanmay.
Yes, login.
Yes. Group 7, Ajit. Group
Done.
7.
Done.
Okay. Okay.
Plugged in.
Group 8, Santonu. Yeah. You've done. Kishore, group 10. Yeah. Okay. I think all got login. Maybe you can start now.
Okay, great. Okay, great. So are you able to see my terminal?
Yeah. If you can just increase the font size, if there is any way.
Yeah, sure.
Go to preferences.
Actually, I don't use Ubuntu much. My primary machine has gone for repair, so expect some glitches from my end. Okay, so okay, great. So the first, yeah. Okay, so the first step we have to do is we need to create an environment. Okay, so environment like you did yesterday for LID, right? We will create a new environment today. So Honda, create name Fairseq Python equal to 3.7. So I'll copy and I'll paste it in the chat window as well. Okay, so Priyanshi is pasting. Okay. I'll press enter.
There is no Conda GUI forum, is it, in cloud? We cannot access that. Arvind?
Sorry, Conda?
GUI form.
Anaconda GUI. No, GUI is not there because it's a mini Conda. It's not that other Conda. So it will ask you to proceed and you have to press Y here and all your packages will start getting installed.
Is anyone present from group 5?
The current user does not have write permissions to required path.
Yeah, I will try to give permissions to that user, Arvind.
Okay.
Yeah.
Sir, same with me. Sir.
Once you execute the command, you press the yes button, your environment would be created. The next step is just to activate the environment and you will have Fairseq written at the left side of your name in brackets.
Yeah, Arvind, I think a couple of groups are facing some issues. We'll wait for them. Yeah.
Yes, sure.
Whoever is not able to create the Conda environment, yeah, please enter their instance name. I will try to fix that issue. Yeah. So one is group 9. If somebody else is facing the same issue, please let us know.
Anirudh, what is the exact problem? That is like sometimes we can't able to create Conda environment.
Yeah, so group 9 instance was not created by us. It was just in the Kaldi. So some user permissions could be different because it writes everything in the OPT Conda directory. So basically, you have to just write permissions to all users. That should fix it.
Oh, okay.
Yeah.
Thank you.
Hello, sir.
Yes, Sachin. Yeah, please.
Conda activate TR SCQ means like lead, LID, before we done yesterday.
No, you create a separate environment for Fairseq. I mean, you don't have to do in LID.
Okay.
Yeah.
No, I go for FIR SCQ, PRSCQ. So it's okay.
So Anirudh, I think you can give permission to OPT, right?
Yes, that's what I'm trying to do. Yeah.
Which is this instance, Salam?
Group 9 instance this time.
Somebody has posted Salam Nandu. I think it's group 12.
Sir, group number 3.
Okay.
Salam, we are getting so much noise from your side. Can you do it? Do something for it?
Okay, I'll see.
Actually, I think noise in his microphone. So if he is remove his headset, then it will gone.
No, I'm not using any external device.
Yeah. So whoever is actually getting that issue of creating that environment, please execute this command. I have pasted the second one, sudo chmod -r. So it will give read write execute permission to every user in the OPT directory. That's where the SIC will be installed. So I fixed it for group 9. Group 3 was also there, so I'll fix it for that too. But if somebody else is facing, please use this command.
Sir, group 2, sir.
Group 2 also. Okay, I will do that. Or you can, yeah, okay, I'll do that.
Meanwhile, Prasanna sir? Prasanna sir is
Yes,
there?
Deepak. Yes, Deepak.
Yes, sir. Can we have 10 minutes break, Harvin? Yeah. Anirudh?
Yeah, sure.
Yeah. So, Prasanna sir would talk about the ISCA. So, they are one of the supporters for this workshop. Prasanna sir, over to you.
Yeah. Thank you, Deepak. Able to see the screen?
Yes, sir. Yes, sir.
Yeah. So, good afternoon, everybody. I hope all of you are enjoying the sessions. I'm watching from morning. Thank you, Harvin, Anirudh, and Sajal for making this happen. Of course, as Deepak mentioned, this ISCA, which is International Speech Communication Association, is supporting this event.
Sir, please, sir. I think Harvin sir have presenting the screen. Hello, Harvin sir. Harvin sir.
We can see.
Harvin sir, maybe.
No, we can watch. No, we are watching actually. Yeah.
Yes.
Maybe in your terminal, Jagabandhu, you may have to. Okay. So, I am presenting on behalf of ISCA as a newly elected member for this board. I think this whole credit goes to all of you who actively participated in the election and helped. Special thanks to Surekant sir, Samudra Vijaya sir, Deepak and Jagabandhu for making this happen. Of course, this association is truly an international speech communication association, which has a lot of benefits for researchers working in the speech processing area, especially for India. So I thought, no, I'll just brief the activities. If you see, you can type this. ISCA may not be International Speech Communication Association. You will get details about it. Let me show you on the website. So if you type this International Speech Communication Association, you will end up in this page. There are a lot of details available here, I think, and a lot of resources are also available. I request you to go through at leisure. I have picked up few points about that. As it's a society which is a non-profit organizations. Of course, if you follow the website, you will come to know. Initially, there was an European Speech Communication Association. Different countries in Europe, they thought the spoken language communication research group should join together and start an association to advance research and development in spoken language processing. Of course, that later it expanded its scope to make it go beyond Europe. Of course, there was an international CSLP also, I think International Communication Spoken Language Processing. Samudraja sir will be knowing. So all of them talked together and brought it under one umbrella, which is called as International Speech Communication Association in 1999. Then onwards, this is the world's leading speech communication association. Of course, the purpose of this ISCA is to provide international world level association collaboration among different groups and researchers who are working in the areas of speech communication. Of course, they support activities including just like our IEEE summer school. Many details are available. You can organize summer schools or winter schools, or you can organize short duration workshop. You can invite distinguished people from the international arena to give talks in your group. Of course, nowadays everything happens virtual. It is easy for inviting them. So as a result of that, we should exploit the rich resources that are available under the umbrella of ISCA for the advancement of spoken language processing in India. Of course, they focus on not limited to, but some of these areas include phonetics, linguistics, automatic speech processing, then also voice pathologies and different areas, all under whatever we treat under spoken language processing interest, they will focus in this particular group. The goal, the objectives they have kept is to simulate the scientific research and education. They help us to organize conferences, courses, and workshops. They will help to publish and promote publication of scientific works related to spoken language processing. And they will try to promote the scientific views related to speech communication. And they always encourage to the study of different languages, especially the languages spoken by smaller community. That is their goal. And they would like to collaborate with all associations. For example, each country, if you go and see in the website, we have a separate association in France, other European countries. They also have a joint agreement with ISCA. Similar thing we can work out for Indian Speech Communication Association also, which Dr. Chandrasekhar Silamantula gave a talk on the second day. Also, they would like to collaborate with, facilitate collaboration between industry and academia to convert some of these research findings into technologies. But of course, now, as I was telling in one of the inaugural talks, now industry research is in the front seat to drive the speech technology development, and also which will in turn feeding back to academic research, just like this summer workshop what we are experiencing. Of course, there is an annual membership for this association. It is about 60 euros per year. If you take up this membership, you will get benefit in terms of reduced registration fee for interspeech and ISCA tutorial and research workshops that will happen. Especially interspeech is one-stop visit for all the community working in the speech processing area. Suppose if you want to meet who is who in the speech processing area, both from industry and academia, this is the place to go. This is an annual conference which happens throughout the world. As Chandrasekhar Silamantala was telling, we had in India for the first time in 2018 in Hyderabad city. Now this year, 2021, it is being held in Czech Republic, Brno. The advantage of attending this interspeech is it is #1 conference in speech processing area. When you publish papers there, you will get attention to who is who in your speech processing area across the world. That is one part. And it is worth for the money and effort that we do to attend this conference, because it's 100% all out speech related activities. So in that way, whole 1 week conference you will attend, morning till evening you will discuss with the different researchers across the world to know what is happening there. For example, the other interesting aspect in this interspeech is I want to bring you all of your attention to what is called special session and challenges, where different research groups across the world, they put up some challenges. For example, some of them are there. I will not read out them. The big advantage is they collect, in many of the challenges, they collect data and make it available freely for the research community to work. Only requirement is you have to work and submit a paper into that special session. That's a good thing. Instead of collecting our own data, you get a lot of data to work and also very challenging problems to work upon. This is one thing I suggest all of you to pay attention whenever you look out for interspeech conference participation. I strongly advocate all of you to aim for publishing your articles in interspeech. Also, make all efforts to attend such events. That is where Dr. Silamantala was telling, Indian Speech Communication Association will be able to support such participation in terms of partial travel grant or something, provided you have an acceptance paper there or something. So that is where I request all of you to pay attention. Also, if you have an interspeech, ISCA registration, you can enjoy a reduced subscription fee for the Speech Communication Journal, which is a Elsevier journal, a well-known journal in the speech processing area. Of course, you will receive a monthly ISCA pad, which is a newsletter from ISCA, what is that monthly activity going on. Then you can also become eligible to organize conferences and workshops at your own institution. Okay, and also you will have free access to the full papers in ISCA archive. This is another resource which I would like to bring your attention. Of course, this nowadays, thanks to the ISCA organization, they have made it free even if you don't register that also. There are resources available. Sorry, I have to go to ISCA. Resources available somewhere, publications. I think somewhere it's online archive. So if you go there, you have all the details available. Whatever they organize, the proceedings, they'll make it freely available. Earlier, it does not used to be the case. If I attend the ISCA interspeech conference, then only I used to get a proceedings. But now, after conferencing, after some time, they'll make it available in this portal. Everything is, compared to the other international associations, the big advantage of ISCA is they are very supportive of activities in nooks and corners of all throughout the world to advance spoken language processing. Especially, they will pay attention to the countries where the speech communication research is, spoken language processing research is not happening to that level. Especially focus is on India, neighborhood countries of India, as well as Africa, South America. Like that, they are paying more attention. Also, the 60 euros is a relatively small amount compared to the resources that we get from them. That's a very good advantage, because this fund, they essentially use it for supporting the students from different countries to attend the workshop, provided they have a publication in that organization or that conference interspeech. So with these things, I strongly advocate all of you, please aim to publish in interspeech. And maybe now we have come together, we can collaborate and also work together and try to publish the papers. Then you are making a real jump to the next level in your group research activity. And thanks to the ecosystem now in India, there are a lot of startups and companies interested in the speech technology development. We can cash on all of these things to really push the research and development both in industry and academia to a noticeable level in international arena with the help of ISCA. They will be very happy to facilitate whatever it is required. For example, distinguished lecturers are there. We have, for example, Professor Susan Boyce from University of City, USA, and our Professor Hemant Patil from DIICT Gandhinagar. They will be very happy to freely deliver the talks in a very recent topics. We can just write email to them and arrange the things, and it is more onto all institutes. It is not that they will only support in some selected places or something. Anybody who is interested, they write to them. They will try to support this. So I request all of you to take benefit of it. And if you have any doubt, any help you require, please come forward. And we also, being India with a multilingual country with so many hundreds of thousands of languages, we need a speech research group in all places in India, nooks and corners of India, and all of us have to get connected and push this frontier to the next level. The first step is taken by Om Prakash Singh from Sikkim Manipal Institute of Technology. Kindly fill up, all of you please fill up the detail. Then share this sheet with other researchers in India who can enter their name so that we can start communicating and working together. I think with these things, I'll stop here unless you have some clarifications. Thank you all. Any of you want to add anything? Samudra Vijay sir, Deepak. Okay.
No, sir. I think that should be fine. You described it nicely, and thanks for Prasanna sir on elaborating on the ISCA this thing. So not only that we have to work scientifically on our Indic languages, but we also have to become transparent and become more legible for the global community as well. So that's how we can forge collaborations and move on. So ISCA is a wonderful platform in that sense. So thank you, sir, for giving all the details about that.
Thank you very much. All the best. Thank you.
Thank you, sir. Thank you.
Yes, I think I'm glad you mentioned the interspeech because not a lot of people know that we also presented our work in interspeech 2021.
Oh, thank you, Arvind. Oh, this is very good news.
Yes, and we also participated in the challenge, which was low resource Indic language in interspeech.
Very good, very good.
This is the leaderboard of that challenge. So we were in top 5.
Oh, great! Congratulations, congratulations. So even I was initially I had some discussion with Vivek regarding with your expertise and with your team effort, we should be able to organize some special sessions in interspeech.
Yes.
So led by Step and ThoughtWorks.
Yes.
So we should put forward and let the international community start working in our Indic languages.
Yes, absolutely. I mean, this year it might not be possible. Maybe next year.
Next year we'll do, Harvey. So
Yeah.
because a lot of planning is required for that.
Yes.
So that way. Thank you.
Yes. The good point here was that there were 5 languages: Hindi, Odia, Tamil, Telugu, Gujarati, and they had given the data set to train our models. And you could use basically any data of your choice to train your model and all. And the average of WER was taken. So the lowest average would be the first. Okay, so if you can check the Hindi WER, we had the lowest Hindi WER.
Great.
All the 24 teams. That
Okay.
was
Excellent.
Yes. So that is why we say that our Hindi model is currently the state-of-the-art model that is present, because it is beating Google, it is beating other company benchmarks as well. Like Unico is a company that is being in speech for the past 10 years, right?
Yes, I know you. Yes. Definitely. Very good.
That's because, Harvin, you think 4,200 hours of Hindi fine-tuning data has made the difference?
Yes, absolutely. Yes. This is the same model that we used here.
Right.
The model that we trained on that data set, we use the same model here.
Yeah.
I think this is a very good news.
Yes. I mean, not a lot of people know because because not very people are aware about this challenge as well, right? So
now on, at least from this workshop, we should expect a lot of teams participating in these competitions, like say IIT Madras, ISCA, or ICAS. So any such competitions, we should expect lot many Indian groups like participating.
We should encourage natural collaborations across groups, so that together we put a system, if possible, so that anyway the goal is becoming more visible in international community by true participation.
Right. And also participating at this level, sir, and bringing down the work.
Excellent.
So that becomes deployable models.
Excellent.
Eventually.
And Harvin, what I feel is, especially international community will be jumping upon all with X-step resources to work.
Yes.
So that is where, suppose we have critical mass here and we also expose international community, then a lot of activity gets picked up very fast.
Yes, absolutely. Yeah.
Thank you, Arun. Thank you for this.
And there was some person who actually wanted a demo, like a real-time demo, right? Somebody asked about the demo. So the website is up. So I can show you a real-time demo. My mic is a little bit, because this is not my primary laptop, so there might be some words here and there, but I request everyone to go on mute so that we can have something. I'll speak something and then you can check the demo if you want in real time, right? So please everyone, if you can go on mute, I'll start. You can, okay, my screen is visible, I think, yes. Okay, I'll start. मुझे बताइए कि ये सब कितना अच्छा क्यों है, और बताइए हम क्या कर सकते हैं। हमें आज मौसम बहुत अच्छा लग रहा है और मुझे लगता है कि बहुत भारी बारिश होगी। So basically this is the real-time demo because somebody was asking. You can see that we are also working on something like inverse text normalization, which for which the punctuation, I mean the Poonviram came at the end of the sentence.
So how do you generate these punctuations, full stop, say comma?
Yeah, I think Nirud will talk in the last day about this.
That session, okay, last session, right? Yeah.
Yes, right. But somebody talked about the real time, so I'm just going to tell you that it is possible, and this model is deployed on the same configuration which you are using currently for training your models. So there is no, I mean, the same machine, the same GPU, the same number of CPU, and everything else.
It's me, sir.
Sorry.
Actually,
Yeah,
I'm actually not.
Sajal sir, yeah, he was the one who.
Thank you, sir.
Yeah. So
Yeah. Hello, sir.
yeah.
Yeah, it is based on which technology, sir? Like networking, WebSocket, or
Again, didn't get your question.
No,
yeah, it
how
is
that
based
real
on.
time has been implemented? What are the tools beneath it? Like,
Okay, so we are using WebRTC for real-time implementation. We are also using WAD. There is a Flask API that we have created on top of the model. Okay, and we are using gRPC server to actually send the stream real-time to the model to get the output from the model. Okay, so I mean, this entire website is also open sourced by us. If you want to deep dive, there is a separate repository for this in which you can go and check the inference portal, what are the different types of things that are being used as well.
so Harvin, we can make use of that and say, suppose we want to host some models built by us.
Yeah.
We can go ahead and do that, is it?
Yes, absolutely. That is the prime reason of our open sourcing. So basically, you can pick up the entire website, replace with your model, and host it at your end. I mean, we don't have a problem with that.
Okay, and whoever tries to speak, we can as well store the data from them.
Yes. As I speak, I mean the data is being getting stored in the backend.
Okay, and is it possible for us to host it on the local server? Is it?
I'm not sure about the local server, but you have to check it yourself. I mean, because there might be some troubleshooting connections here and there, but I think you might be able to do it. But we have not tried it at our end. Yes. So similarly, we also have a transcript facility in which you can upload your file and the subtitles of the file will be generated accordingly. So this works only for the first 5 minutes of the audio. So I am not giving you the link as of now because the link is not scaled up. Okay, so this is running on a single machine at a time only 5 to 10 users can actually access and test the models because there are 8 models deployed on a single machine. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 models deployed on a single machine. Okay, so this machine is not scaled up, but we use for our internal demo or maybe to show someone how our models are working. Okay, so I can run a similar for English. So English, I think this model, I don't know if this is a new model or not, but there is some, I mean, you might see some words here and there. Hindi was quite good. The spellings were good. Let's try with the English model. So let's try with the English model. I hope Anirudh has deployed the right model. Anirudh. Okay, so Anirudh lives in Muzaffarnagar. Okay, so Rahul Dravid hit a century yesterday. So as I said, I mean, there are a couple of words that are getting lost in between the transcription, but most of the times, now you see, I have stopped. There is automatic capitalization that has happened. I mean, on the English, E has become capital, on Anirudh, A has become capital. Then the dots has also come in the output of model. And there is a comma as well after OK. So this all punctuation is working. This is also all open source. If you want to do it on your models, basically you can do it as well for your model.
And it also is like auto corrected, like Rahul traveled, then it translated to Rahul Dravid. How it is like? Are you doing post processing or what?
So it is a language model basically. So first of all, there is a stream of data that is going on. When Rahul Dravid was said, might be possible that some part of Dravid might have got missing in the stream. So when it received a stream after hit a century, so Rahul Dravid hit a century, it became a proper sentence, and the language model actually did its magic afterwards. So language model goes back and checks what is the probability of these two words coming together.
Okay, thank you. Yes.
Okay, so I think this is just the starting. Okay, as I said, I mean, as everybody said, this is just the starting of speech ecosystem. we can create much powerful tools. We can create an Alexa in Hindi, we can create Alexa in Tamil. That is a wonderful project if you are a college student. And even I am working on something similar on the grounds of something similar in my personal space. But this is just the starting. I mean, you can see, I mean, with a considerate amount of noise in my backend, because my mic in Google is coming through noise cancellation, but there is no noise cancellation in the website. Okay, so essentially there is noise coming in the mic, and with all this noise, the prediction is pretty much good.
Yeah, it's really good, Harvind. Yeah.
Yes.
So have you ported say this wave to wake to say when you say Amazon Alexa sort of thing?
Yes.
Have you ported it to some edge device?
No, see, because this works on real time because it is working on a GPU.
Mm-hmm.
So I have created an API, okay, so which I can hit from the edge device.
Mm-hmm.
Okay? So basically, my only motive at that point of time is to wake up the device. So I'm just doing a wake up detection at the device, and once the wake up detection is done, I am sending my query over the internet to an API that is hosted somewhere to get the response from the API.
Mm-hmm. Have you used the multi-array microphone device?
No, I'm not aware of that.
Okay, yeah, please. No issues.
Yes, so this was a working, and I'm really sure if you can spend some time after this workshop on our GitHub links and all, you will be able to create a similar website, you will be able to create similar models, and believe me, it's no rocket science, okay? Everything is doable. It just needs a little bit of time investment from your end, right? So that's it. Okay, so I think we should proceed. I think most of the groups are done. 1, 5, 6, 4, 8. And thank you, Samudra Vijay sir, for the compliment. And Anirudh has posted the GitHub repo. Okay, so now is the time to bring the code to your machine. Okay, our experimentation platform to your machine. The command here is very simple: git clone, and then you have the address of the repository. -b is a switch for what branch do you want to bring in. As you go to experimentation platform, you'll see that there are a lot of branches here: v1, v2 Hydra, dev, main. I have created a specific branch for this workshop that will remain even after this workshop, so you can come and try at your end, or maybe you can fix some bugs and then maybe create a pull request at this repo or so on. Okay, so we just want to bring the IEEE branch. I would be posting, okay, Priyanshi has posted this in the chat window. You execute this command and you will be getting a folder with name Vakyansh Wave 2 Vec 2 experimentation. So please do this. Once you're done, please post in the chat window with your group number and -done. Great. 789 is done. Okay. So the next step is you move inside the repo. So you cd into Vakyansh Wave 2 experimentation. Okay, 4 is done, 11 is done, 1 is done, 1, 2 is left, 6, 5, 2. 2 is done. Okay, 3 is left. 3, 4, 5. Okay, group 3, what is the problem? 4 is done. Only 3 has a problem, and 5 is done. Anirudh, there is still some problem.
Yeah, I didn't do it in group 3. I posted the command. Okay, I'll do it on group 3 as well. Okay,
yes.
Yeah.
So only 3 is pending. 1 is done, 2 is done, 4 is done, 5, 6, 7, 8, 9 already done. Then I don't see a response from group 10. Is there a group 10? There might be group 10, right? So 11 is also done. So how many groups are there? 11 or 12?
11.
11. Okay. So 10 is pending. Anybody from 10 who can respond? Eight, 9, 11, 1, and 6.
From group 10.
Anybody from group 10? Okay. Is it done?
Kishore from group 10, are you able to do?
Are they in the call? Let me check. I mean, what's the name?
Yeah, Kishore, yes.
Okay. Because once this is done, then there is a step for installation. You just need to execute the bash script and just wait for errors to come, if there are any. Ideally, you won't be facing any errors, but if there are any errors, then we will solve it one by one. But at this step, everyone should be at the same level, okay? So group 10 is pending, group 3 is pending. Group 3, can you try now creating an environment? And see, even if you miss some step, don't worry. I mean, everything is documented in this repository. Okay, so it is not that we are doing this for the first time, and it is not that we are doing this for the last time. Okay, we will always have these things. So don't worry about missing something. You will also have the recording for this session available afterwards. So don't worry about missing anything. Group 3, are you able to create your environment?
Yeah, Salam, now are you able to do?
Salman is not there in the call, I guess.
Yeah,
Salman
he's
is
there.
there. He is
Salam.
there. Yeah.
No, I'm doing.
Yeah, okay.
Okay. Once you're done, please let us know so that we can proceed further. So before executing the next command, you just have to make sure that you are in the FairSec environment that we created. Okay, so FairSec would be written at the left side of your username inside the machine. So please make sure that you are within that environment. Okay. So for others who are waiting, let's start the process because some people might get stuck here inside the installation. We'll continue for group 3. So the next command is bash setup new environment.sh. So there is a file called setup new environment.sh. So what you have to do is bash setup new environment and press enter. If it asks for anything, please press Y. Okay. So it will install a bunch of things. So let it install. It will also take a little bit of time. Let it take. No issues with that. Once you execute the command, you'll see something like you see on my screen. I am also creating the environment with you. So you may see a similar kind of things happening at your prompt. Okay. So this would take around 10, close to 5 to 7 minutes for the complete process to get executed. Any error, if you encounter any error, please let us know. Ideally, you should not, but if you do, please let us know. Okay, so CMake greater than is required to build flashlight. Sai, you're on which machine? Local server. See, you need to update your CMake environment, which depends on the operating system that you're using in your local machine. If you are using anything less than 18, then there is a problem. Which version of Ubuntu? So once this command ends, you'll get something like finish processing dependencies of flashlight 1.0.0. If you get this message, please go to the chat window, write your group number and write installation done. Perfect. Sai, I think we need to troubleshoot a little bit more on your local server. Anirudh, can you help him?
Yeah, I'm trying to look into it. Yeah, I think yeah, I will talk in the chat. Sorry.
Okay. So group 8 is done. Okay, very well. Group 8 is the fastest, I think, every time. Group 8 is done. Group 7 is done. So I just want you to do a small check whether everything has installed correctly or not. So how can you do that check? You will do ls opt first of all, and then there will be a folder called web to vec, and you check there are 3 folders: faresec, flashlight, and Kenlm. 11 is done. 8711 is done. ls/opt/web to vec, and you check there would be 3 folders: faresec, flashlight, and Kenlm. Okay, group 1 done. Group 4 done. 9 done. Okay, Shruti, thank you for confirmation. Group 9 done. Group 5 still downloading, no issues. We'll wait for you. Group 2 done. Group 3, are you stuck somewhere or you're able to proceed? Okay, group 3 running. Great, great. Great, great. Yes. Yes, Ajit.
Sir, for group 6, I actually lost my internet connection. I had to re-log in and then I'm doing it again. So it is downloading and hopefully it should complete.
Okay, yeah, no issues. You just activate the environment and execute the same command, bash set new environment.
Yes, I have done it like that, sir.
Yeah, yeah, okay, no issue. Sridhar. There are only folders I am able to see. Sridhar, there is no wave to vec folder in your. Did you get the flashlight installation message? Anirudh, can you log into group 2 and check?
Yeah, this is group 2.
I think group 8.
Is a group?
Group 8.
Yeah.
Group 8. Sorry. Group 8.
Group 8 is it? Okay, I will log in and check.
Yeah. Yes, Sai, that is right. So I'll come back in 5 minutes. I'm taking a water break. Okay, so let's see what happens after 5 minutes.
Okay, okay. Yeah, hello, Santanu Kumar. Hello.
Hello. Yeah.
No. I'm asking for Santanu Kumar. Yeah.
Okay. Okay.
Santanu Kumar, can you do it for group 10? Actually, I think Kishore is not responding. So can you do it for group 10? Santanu Kumar or Devadarshini. If anybody you guys can do, you can do it for group 10. Okay. So Devadarshini.
Wait, group 3 done, group 6 done, 7 was already done, 8 was done. Okay, I mean, who is left? Just post it on the chat window that you're still doing, so that we know that you are doing. Group 8, okay. Only group 8, rest everyone is done. So, group 8, can you share your screen? We can check quickly.
Yeah, I'm doing it, Harvey. I can share maybe. Yeah, so for group 8, yeah.
Okay, you solved manually instead of that script, okay.
Yeah, I just ran the script, it's running, so just wait.
Okay, so even if you installed manually, that is perfectly fine. The instructions are here. You just have to make sure that all of these 3 folders are there. I mean, the Fairsight, Kenlm, and Flashlight, because you can see that there are 3 clones, right? So it doesn't matter where is your folder. What matters is that it should be present. That's it, and you should get a successful installation message. Okay.
Yeah, I
so
think he installed it manually. That's why they were not created in OPT.
Yeah. See, that is perfectly fine.
That's fine.
Yeah, that is perfectly fine.
Yeah, I think now this is also running. Let it just.
No issues. Let it run. I mean, let's check once again.
Sure.
Okay.
Yeah.
So, to other participants, you have 2 options. One is to manually install everything. One is to install Fairsight manually, Kenlm, which is a language modeling library, and Flashlight is a decoder, and it provides the CTC decoding that we talked about.
Arvind, did we use CUDA equal to 0 in the instructions?
No, I mean this has a GPU on.
Yeah, this has, but it's failing in Flashlight. No?
Okay, let me check. No, we haven't.
Okay.
So you can export use CPU equal to.
There is those instructions that will be
export use CUDA equal to 0.
Export use underscore CUDA
equal to 0. So everything else is installed apart from Flashlight?
Yeah, I'll just maybe just look at the Fairsight one.
Can you check NVIDIA SMI?
Yeah, it is running.
Okay.
Okay, so I'll just go inside this and okay.
You delete the folder bindings. OPT wave to wake.
Yeah. So I'm inside this. Then Flashlight.
Flashlight. Bindings Python.
Bindings Python. Right.
And remove the build folder.
Yes. Now this, let it just export this mode and Python. still getting the same issue.
Can you scroll up? What happened? Okay, so Kenlm also you have to set once.
Okay, yeah, got it.
So you go back to Kenlm folder.
Yeah. NLM. Okay, you tell me the instructions related to it.
OPT Kenlm, go to
NLM.
OPT Kenlm. OPT you do it Kenlm, and now you export Kenlm underscore. I will pass on the command.
Yeah.
In chat.
So the same folder you want to export as Kenlm root, right? This one.
Yes.
Okay. Now do I have to build Kenlm again, or is it fine?
No. You just have to export use MKL0 again and use CUDA 0 again. You go to flashlight, binding Python, remove build. Binding Python. Python.
Yeah. rm-r build. Okay.
And export the same. Use MKL equal to 0.
Right, now I can transfer.
Yes, so Salam, there I mentioned nothing afterward. It's just that we are fixing one machine. No, Sai, you don't have to change anything if you are using multi-GPU.
Okay, it's fixed now. Cool.
Okay, great. Okay, so this was group 8. Group 8 is fixed. Everyone is already done. I'll resume my screen. Okay, so now the first thing that what were the commands used to disable CUDA? So here, if you go to this repository in manually install, for CPU you can use export use CUDA equal to 0 in the installation of Kenlm. Just export use CUDA equal to 0. Okay. So now I think is the time to get your data. Okay. So data that we will be working on, data that was provided by IIT Madras in this competition. So we will be getting 40 plus 5 plus 5, which is 50 hours of data. So I've already downloaded this data and I have pre-processed some parts of this data. So to get the data, I think there is a folder called timeline in this branch. If you can open sideways, you can open. So it's in MD 1_data preparation.md file. So okay, so now what you have to do is you were inside the Vakyansh Wave 2 at experimentation folder. You don't need to change anything inside that folder. So come out of that folder. Okay, so cd dot. Okay, so now you are in your main repo. So what you have to do is you have to create a directory called data. Okay, so I will create a directory called data and kdir data and just go into that directory. Okay, so all commands are here. Then you need to do wget to get this data. Once you hit the wget zip, it will start downloading the data. Okay, just complete up till here. So I am also downloading with you, so you will get a similar screen in which in the IITM challenge would be getting downloaded. Okay, it has a file of 4.6 GB, and once it is downloaded, you can do ls, and you will be able to see in the IITM challenge.zip. So once you download the data, you do unzip this data. I mean unzip and the name of the folder, and it will start inflating like this.
Those data corresponding text and transcription.
Yes, so it is audio plus transcription. Yes, so it's labeled data. Okay, so it's 40 hours of labeled data that was provided by IIT Madras. Okay, and this is Hindi data. Okay, so 5 hours is the dev set and 5 hours is the evaluation set. So by doing this, we have downloaded 50 hours of data. Okay, so once this completes, you'll get something the screen like this. Now you'll do ls.
Hello, sir.
Yeah. Hello.
Sir, actually my internet connection got disconnected, so I'm relogging it. So sorry.
Okay, no issues, no issues.
It was extracting in the midway. It got cancelled.
No issues. You can extract again. No problem. It will continue from the same point.
Okay, sir.
So once your data is extracted, I would request you to delete the zip file because we want to save some space. So you do rm and hindi iitm.zip. So if you execute this command and you do ls, then your zip file would be gone. Okay, group 1 done, group 2 done, group 4 done. Group 8 done. Okay, group 6. Okay. 4 done, 7 done, 6 is left. Whenever you use an internet connection and you re-log into the instance, always make sure that you are activated in the environment. Okay, so always make sure that fairsec is written on the left side of your name. Okay, it shouldn't be base or any other name. It should be the one that we have done. Okay, we have created. Anyone left? Any group left? If you're left, then you can please post in the chat window, because now we will be starting with the exploring of data. Okay, group 9 is okay, doing okay. Only group 9 is left.
Sir, actually, while I was unzipping once again, it asked me like if I want to replace the data, or like yes, no prompt it came. So, so what should I do?
You can do yes. Yes, you can do yes.
So it's asking for every file.
Okay.
So
Yeah,
I'll delete
I
and
think you
do
just
once
delete
again.
that folder and unzip again. Yeah, that would be
You can delete the folder and unzip again. I mean, ideally it should be yes for all. Okay, but group 9 left. Issues. People who have downloaded the data and extracted successfully, they would be able to see something like raw. Okay, so it is always a very good practice to keep your data separate in production machine learning systems. So raw means the data that was received as it is from IITM. Okay, so it means that no processing has been done on the data. So if you will do some processing, then you will create another folder called processed. Okay, and basically you will put your data in the processed folder. But it is a good practice that you never change whatever is present in the raw folder. Okay, so let the group 9 finish. So people who are inquisitive, they can actually go to raw, and if you do ls, you will see 3 folders: dev, eval, and train. You can check here: train, dev, and evaluation. So we will do a training on the train set, and we will evaluate a training on the dev set. And okay, very nice. Okay, so if you go to raw, you find 3 folders. One is train, dev, and eval. And in train, you have the training data. In eval, you have the evaluations data set. And dev, you have the dev set. So what exactly happens in machine learning or deep learning is that you train using the train data. On the dev set, you optimize for certain hyperparameters. Okay, and I mean, you do whatever hyperparameter optimization you want to do on the dev set, and on the eval set, once you're done with the hyperparameter optimization, you check what is the performance of your model on the eval set. The basic part here is that neither of the dev or the eval data should be present in the training. Okay, because you're training your model and you're trying to see whether your model is performing better on the data that it has never seen before. Okay, to check that, you create separate dev and eval sets that may have different speakers, that they have different dialects, that may have different environments. Okay, so you during the training time you evaluate the performance of your model on the dev set. So once your training is done, you just report your statistics, final statistics on the eval set. Okay, any questions still now? I think that's a very basic machine learning data pipeline, right? So you have 3 sets. Okay, so these are already segregated because this was the competition data that was provided. So during the competition, they just provided the train and the dev set, and they provided a portal where you can submit your decodes, and they would check on their end on the evaluation set, and then they will let you know the WER. But since this competition is over, they have released the entire data, that is train, dev, and evaluation data. Okay, so now we have 3 sets of data. Okay. Okay, so the next task here is, I want to explore what are the properties of audio. So first of all, I want to explore what is the requirement from the data side for wave-to-vec. So the requirement for wave-to-vec is that your data should be in utterances, okay, and one utterance should not be greater than 20 seconds, okay, due to the limitation of GPU, okay, and your text and wave should be present in the same directory with the same name. Okay, I'll show you a small thing. So I'll go to train. I'll go to train folder, and I'll do ls head -10 because I do not want to print all the entries. I just want to print the first 10 entries. Hence, I'll do ls head -10. So you'll see that this is the file name, which is the text, and this is the file name. With the same file name, you have a wave file. Okay, so the contents of the wave file, that means the transcription of the wave file, is present in the text file. Okay, and so on for all the other wave file and text file. So basically you need to have a pair. Okay, so a pair of wave file and text file for the training data. Okay, so you need to have a pair for the wave file and the text file with the same name essentially, but a different extension. So wave contains your speech and text contains your transcript that is present in that particular portion. Okay, so wave file cannot be greater than 20 seconds due to the limitation of GPU, and there is, as I said, a pair present for every name that is in the form of text and wave. Okay, now if you want to check the properties for the text
Excuse
file,
me, Harvey.
yeah,
Yeah, if all my text is in a separate text file, like all the utterances of here, they have their text in a separate text file. So do you have scripts to make it, put it like this?
yes, we do have scripts, and you can write your own as well. The only part here is that you need to have one text file for every segment. Like in Kaldi, you have a single text file which contains all the data, right?
Yeah.
But for wave-to-vec, you need to have a different text file for all the different files.
Okay.
Okay. Similarly for wave, you need to have a different wave file for all the different waves.
Okay.
Okay. So now if I want to check the properties of audio, so there is a command called sox-i, which stands for sox information, and I will just type the name of the file I want to see the information for. Okay, so it is 1.wave. So when I do soxy, the name of the wave file, what I get is the number of channels, the sample rate, precision, duration, file size, bitrate, and sample encoding and all. What is useful from here is, and what we need to ensure is, that the number of channel is 1. So if you have audio that is dual channel, if your number of channels is greater than 1, then there is a script. I mean, you probably have to write a script in SOX. We already have that script where you convert from a dual channel to a mono channel. Okay, and if your sample rate is say 32,000, you basically lower that sample rate and come down to 16,000. Even if it is 8,000, you upscale and move to 16,000. So that is the requirement for wave to wake. That is not our requirement. That is a requirement of wave to wake. Okay. And similarly, if you check other files, I'll check some other file just for the other wave properties. So the number of channel is 1, precision is, sample rate is 16,000, duration is 2 seconds. Okay, here it was 8 seconds. Okay, so this is basically how you can check the information on your wave files, and you have to make sure whenever you're starting any wave to wake training that the channel is 1, the sample rate is 16,000. If it is not, then you probably have to write a script that brings from a dual channel to a mono channel, and that if the sample rate is not 16,000, then it brings that to 16,000. Okay, so basically it's very easy to write a script in Python to do this task. We may have already written in some script and we can also provide you that script. But the question here is single channel and sample rate should be 16,000. Okay, any questions up till now?
Arvind, in case like if it is 8K, right? If the training data is 8K,
yes,
we need not upsample it to 16K, right? We can as well give 8K samples.
No, actually, you have to see when your data is 8K, even if you move to 16K, it will be zeros.
No. I'm not saying that. Computation time will also be higher, right, for training data.
Yes, but this wave to wake works only on 16,000. Because there is some hard coding that has been done with respect to sample rate. The FAIRSEC team is changing, and so that people can train at 8K, 60, 32K, 4K as well, right? But the current algorithm works only at 16K.
16K.
Okay.
I think all the parameters are tuned or optimized with respect to 16K as the sampling frequency.
Yes, as the input.
Yes.
Yes. Okay, so this was how you can get the information on your wave file. Unfortunately, we cannot listen to wave file because we are on cloud. If we have to listen, we need to open a Jupyter notebook and a bunch of stuff. I don't want to do that. But we can surely view the text file. Okay, so to view the text file, what you can do is just basically cat and pick the name of the file. So cat and text. So you see that there is a text that is written. अपने अध्ययन में इस बात का खुलासा किया है कि करीब 149 वर्ग किलोमीटर में फैले कभी लुभावने नीले रंग का दिखने वाले. Okay, so here you can get the text if you want to check the text. Now you have the training data with you. Okay, so I just want to check your understanding. Just try to view different files and let me know in the chat window what problem do you see with the text. What can you think be the problem with the text?
Sai Ganesh has he has raised a hand.
Yeah. Please go ahead.
Sai Ganesh.
Please show the sentence again.
Yeah, sure. I'll show the sentence. Maybe you can, I can show some other sentence as well. Okay. So maybe you can get an idea like what is wrong with the sentence. I mean, what can be the wrong thing with the sentence?
What is this BN tag in between?
Yes. So I think this is the transcript that we have received from IIT. Okay. So this is something that we have to figure out what is BN and what is SIL in the starting, right?
BN is background noise.
Yes.
It is background noise.
Okay.
So that means silence is in front of the sentence.
So the problem here is that within the transcripts, there are some characters that are not of language. Okay. So SIL doesn't belongs to Hindi language. BN doesn't belongs to Hindi language. And these denote certain things like laughter or maybe excitement, or maybe SIL means for silence, BN means for background noise. So this everything is not useful or for a wave-to-wave model. Okay, so we need to clean our transcripts. Okay, so our transcripts are basically unclean. Okay, so basically you need to remove the BN from this sentence. You basically need to remove the SIL from this sentence, and you have to make sure that whatever is there in the transcript is of Hindi character, because we are creating an ASR for Hindi language. You have to remember that. Okay, and for Hindi language we only need characters that are there in Hindi. We don't want a English ASR. Okay, if we want a English ASR, then English characters are fine. But if we just need the Hindi characters, then we have to remove these characters before proceeding. Okay, so what if precision is different? I mean, one is 16-bit, other is 32-bit. You have to bring it down to 16-bit, Sai Ganesh. Okay, so I think if the precision is different, then the sample rate would also be different. So once you change the sample rate, the precision might also get changed as well. I'm not quite sure on that, but yes, I think it is there. But the point here is channels 1, sample rate 16,000, precision 16-bit, and bit rate can be variable. It can be 400K, rate can be 256K, 128K, depends on the quality of audio. But these three things have to be the same. Okay, so I'll just again open. Sorry, not cat. So ls head -10. I'll open 2-3 text files to clearly show you that what are the different types of English tokens that are present. So these tokens may have been introduced by Kaldi, or they may have been introduced by some hand labeler or something, right? And so let's check. I mean, I'll pick this file and I'll look at. So again, you can see there is a silence in the starting of the audio. We don't care about the silence, whether it is present or not, but we do care about the fact that foreign characters should not be present in the transcript if we are creating a model for Hindi. Okay, if we just want to predict for Hindi. Okay, and I'll check this file as well. So see, in this file, there is no foreign character. So that is a perfect transcript that we can get. Okay, so this file is okay. We don't need to clean this file. But when we run the cleaning script, we will run on every file, so that in case if we miss some characters visually, they are taken care of in the script. Okay, I'll just open one more file, so then we can proceed further. Now you can see in this file as well, SIL is present. Again, we need to clean this because we cannot afford to have foreign characters in our transcript. Okay, any questions up till now? Does everyone agree that we need to clean the transcript? Okay.
I have a question here.
Yeah.
So here we are in this case they have made this they have put this cell maybe for the silence during the start of the audio file. But now if we remove this, are we going to replace with something else, or we're just going to keep it as it is?
So if we remove this, we are going to remove the entire token. Okay, we are going to replace it with a space, with nothing. Okay, so that there was nothing here. I'll come to the script part. Okay, I'll show you the script which does this thing.
Yeah, but then for this particular file, the corresponding audio file should also remove the initial silence. Like there should not be silence. Then
Yes, so that you don't have to take care of that. The algorithm will take care of the silence.
Okay.
Okay, but you don't need to tell the algorithm that there was a silence here. That is the point. Okay, that is, you leave up to the algorithm to figure out. Okay, what you need to ensure is that your transcript is clean, and with clean the meaning is that it doesn't have any foreign characters that are not present in the language we are trying to build the ASR on.
If numerical values are there, then we need to clean.
Yes, so in numerical values you need to take a call. Okay, so a call whether you want to have those numerical values or not, because see, in Hindi numerics, I mean, if you ask me, so like 1, 2, 3, 4, and then there is 11, 12. So if in your training data set you have all the numerics that are spoken and you have the corresponding 11, 12 there in the transcript, then it is perfectly fine. But what we do here at Xstep is we don't keep numerics in the transcript. Okay, so transcripts that contain numerics, we delete them altogether from the training data. Okay, so you have to make sure. Okay, that is a good question. Let me just open a text editor to clear this doubt. Okay, so suppose in your audio file, this is the audio. Okay, I'm writing the audio, but assume that this is the audio. That suppose Harveen is working from past 15 months in Xstep. Suppose this is the audio, and in the text file, you have Harveen is working. I mean, essentially the same sentence. Okay. Now, what your point here is that you have to take a call that whether 15 would come in your transcript or not, because if you are creating a model in English that can only contain characters from A to Z. Okay, so you cannot have 15 there. Okay, so one thing is that you remove 15 altogether. You remove 15 from the transcript. But then this audio to text mapping is wrong, because in audio 15 has been spoken, but from the text you have removed 15. Right? So this means that you are intentionally creating wrong data, which is wrong. Okay, so what you have to do is you say that you will not take this audio and text, both of these audio and text in your training data.
Excuse me, sir. If I write FIFTEEN?
If you write FIFTEEN, then it is perfectly fine.
Yes.
Then it is perfectly fine because it is in A to Z, right? But if there is 15 and you remove 15, then this is wrong. This is wrong. You have to delete both the text and the audio from your training data. Okay. But if you replace 15 with 15 here, let's say, then it is 100% right. Okay. Because this text doesn't contain anything from the foreign characters, right? Apart from these characters.
Excuse me, Harvey?
Yeah.
Yeah, if I include even the numbers in my dictionary, like you said, you will include A to Z in the dictionary, right? So if I include numbers from 0 to 9 also, can I?
Yes. If you
then
include,
it will be
yes,
fine?
if you include numbers, then this is right.
Okay.
If you include numbers, then this is right. But we intentionally do not include numbers because different numbers have different pronunciation. Okay, like how do you ensure that 76 comes at 76? Okay, like we created a model in which we spelled like 5 lakh. Okay, so one representation of 5 lakh is this, another representation of 5 lakh is this. So now tell me how the model will decide what is there and not, because your transcripts become inconsistent. So if you have two sentences in which 5 lakh is written like this in the first sentence, and in the second sentence 5 lakh is written like this, then the model will get confused that what does 5 lakh means, whether it means 5 space lakh or whether it means 5 followed by 5 zeros.
What you mean is you don't want the symbol numerics, you want sound representation.
Yes.
Sir, then it would be better if we do some sort of text normalization before in hand, right? If there are some numbers, just replace it.
Yes.
Yeah. So just to answer that, Sai, so we can do that, but numbers can also come in a variety of contexts, right? So if you use just one top-of-the-mill type of normalizer which just does number to words, that will just do counting, right? But it can come in context of addresses, and it can come in context of time, and it can come in context of currency and so many other things. And all these kind of digits are pronounced very differently. So maybe your PIN code is pronounced in the audio, but since you did it using num2 words, your words would be 225,000 or something like that, but PIN codes are not pronounced like that, right? So normalization also, if we have to do, we have to be very careful.
Then how to retrieve this back, sir? I mean, assume that, okay, this we are discarding, this transcript we are discarding. Then how to get even such variants in our model?
It becomes out of vocabulary.
Yes. So you discard both audio and text. You don't just discard text. You discard both audio and text, and you allow the model to understand numbers in the form of text only. And maybe after you're done with the prediction, you can do an inverse text normalization to convert words into text.
Okay.
Okay.
What are the tools for inverse text normalization, Arvind?
Anirudh will talk about on the last day.
Okay. And also, see, especially coming to financial data, banking applications, numbers become so critical, right? So what is the kind of accuracy the system will have if we deploy ASR for such numbers?
I think we were getting quite good in the terms of numbers because we used a good language model after the ASR output to get correct numbers. Okay, but still, I think this is experimental in Hindi. In English, it's quite straightforward. Okay, but in Hindi, you have a different pronunciation for every different pair, right?
Correct.
21, 22, 23, 24, and you can't manage to have every number in your training set for the model to learn.
Right. Correct.
And just one representation of a number is also not enough in the training set. So you cannot say like if 21 comes 1, then the model will know that 21 is 21. Okay, so that is a little bit hard. Okay, so in English we are able to build a number with model. Model with numbers, but in Hindi we are strictly saying that we are avoiding all the numbers, and we are allowing the model to predict numbers as a form of words only. And maybe we can create a model on top of the words that can convert words to number in the post processing.
And is there a smart way, say for example, in language model, if we keep on adding all the dictionary in the numbers, it grows like anything, right? If all possible numbers. So what is the suggestion in that case?
So see, the language model the characters in the language model have to be the same on which your model is trained on. That is a limitation here. Okay, so if your if your ASR model had a character range of A to Z, then your language model will also have the character range from A to Z. It cannot contain numbers.
No, I agree. But this one, vocabulary list we build, right? So that becomes too large. Like say 1,000, 1,001, 1,002, 1,003.
Yes.
Yeah.
So that is, I think, in this we have a library called Kenlm, which takes care. I mean, our vocab size is 5 lakh. So it takes care of that 5 lakh.
Till 5 lakh. Okay.
Yes, it takes care of that. And there is literally no issues with that language. That's a very basic statistical language model, which tells like what is the probability of two words coming together. Okay, and then it combines that with the score of the entire sentence, and basically a beam search is done. Okay, a beam search is done, and 128 alternatives are proposed, and we have to select the best alternative with the best score. Okay, so we'll talk about the language model tomorrow, but the problem here is that we need to keep our audio and text consistent in as much way possible as we can. Okay, now so there is SIL here. Now you have to understand that silence cannot be pronounced in a video. Okay, so nobody can say silence and then there is a SIL here. Okay, so that is why it is okay if we remove SIL or BN, because we know that these are the tags that have been tagged by somebody who was taking care of the background noise, who was taking care of the silence and all of those things. Okay, so we knew that these are the tags that are present in Kaldi and we can remove them safely. Okay, and this will have no effect from the audio text mapping. But in this
by doing that, what we are doing we are decreasing the robustness of the system.
How?
That means suppose background noise is not, we are transcripting, and silence also we are not transcripting. So suppose during the text time, that suppose background noise is there. Suppose I'm talking and behind somebody is talking, so background noise is there. So that means the system will not able to recognize that much by doing.
No. See, what we care about is this text.
So it is Lalaram, your question is valid. Like if we were dealing with GMM, HMM, or any such things, right? So here in this case, it's a character mapping. So it's a acoustic wave to character mapping. So all that we are worried is BN is not a character in the English.
Just one more thing. So removing BN from here doesn't mean we are removing background noise from the audio, right?
Okay.
Audio background noise is still there. And the stretching of the audio or the removing silence, the alignment is happening due to the CTC loss, right? So we are not.
So that means we are using in training background noise is also we are using.
Yes, absolutely. See, at no point of time we are changing the audio. Okay, here we are just talking about changing the text, cleaning the text. Okay, in audio we can have certain measures in which we can include background noise from other channels and to make our system more robust, but we won't be doing that. I mean, you can augment your audio, but here when we say that we have to remove the BN and SIL, we just have to remove it from the text, because anyways you don't know that how much part of the audio is silence. Okay, there is no way for you to understand. Suppose if in the audio first 4 seconds are silence, but how do you know first 4 seconds are silence? You don't have any I mean word level mapping of the timestamp mapping of the audio, right? What you have is the audio and the text, and what we are saying is we remove the foreign characters from the text, we'll keep the audio as it is.
If I'm training an English model, so can I have that SIL and all?
Yes, if you are training an English model, you can have SIL, but then what would be the prediction of the model? I mean, because there is silence there, and your model is if you want your model to predict SIL in production, if you want that, then only have SIL in the training data. Okay, so like I showed you a demo on the website, right? So there is no silence or background noise coming in the final transcript. I don't care about silence or background noise. What I just care about is that whatever I speak is displayed on the terminal. Okay, so if you just care about that, then you do not include the silence and BN. You also have to remove silence and BN from the English transcripts as well.
Okay, thanks.
Okay, I'll open what was there in. So we have analyzed the audio properties. We have analyzed the transcripts. So if you want to check the total number of files, so let's go ahead and check. Let me check. So ls 5wc minus l. If you do this, you'll see that there are a total number of 54,262 files in the train folder. Okay, you can check that. If you just want to check what are the number of WAV files that are present, that would be exactly the half of this number, because we know that there are pairs of WAV and text files. Okay. Similarly, if you just want to check the text file, WC minus L, you get the text file. Okay. So now the main part is, how do you check the total duration? I mean, because see, if you're working with image data or text data, it is very easy to find out how many images do you have for training and all. But here also you can check what are the total number of WAV files and text files present. But how do you calculate the amount of audio? I mean, whether it is 40 hours, 10 hours, 20 hours, 30 hours, because that is also a very important metadata that you should take care of. Okay, so to do that, command is already mentioned in this timeline page. So we have created a script which is in Vakyansh, and then go to utils, and then audio, and then duration, and then you give the path of the folder of which you want to find the duration. So I have a data folder here. So data, raw, and train. If you just execute this command, to tell you number of files present is 27131, and now it is calculating the total duration of the audio files. And the total number of data in hours is 40.19, which was exactly what was provided to us. Train data was 40 hours. Okay. So this was on the training data. A similar check you can do on the valid set. Oh, sorry, valid doesn't exist, so dev exists. Dev set only contains 3000 files, 3330 files, and it is of 4.97 hours, which is closer to what the challenge gave us. I mean, close to 5 hours. And similarly, on the eval set, you can also run and check the duration. Okay, so total number of data in hours is 5 hours. Okay, so I think now I'll give you a short demo. I think Aniruddha has already given in the doubt clearing session on how to use JobLib, how to use the maximum power of CPU. So I'll just quickly go through, and I'll just maybe in 5 or 10 minutes we can have a small tutorial on how to use all the cores of CPU. Okay, so what is the point? So you don't have to do anything, you just have to see on the screen. I'll basically code and I'll explain you what is happening and how it is happening. Okay, so I'll open this file. So what I'm doing is basically I'm iterating, let's do it 60 here. Basically I want to run a for loop 60 times, and each time it calls a function called test function, which is this one. And here time.sleep and the duration is provided, which is always 1. So what does time.sleep does is it the thread sleeps for a second. Okay, so essentially if you are running a for loop, this would take 60 seconds to run. Okay, because every time you're calling the function, it would go ahead and it would sleep for 1 second in every iteration of the for loop. Okay. Any questions till now? So TQDM is for the progress bar. Okay, so if you want to see a progress bar in the terminal, then we use TQDM. So ignore TQDM. The only part here is that we are running a for loop for 60 times, and each time what we are saying is sleep for 1 second, sleep the thread for 1 second. Okay, and if I run this, program, you'll see how much time it is taking. 58 seconds, 56, 55, 54. So basically, because on every for loop I'm sleeping for 1 second, so to do 60 entries, it would take 60 seconds, because Python is a single threaded thing which essentially works on a single thread by default. Now at this point of time, only 1 core out of 8 cores is being used. 1 core out of 8 CPU cores is being used. Okay, but if you want to actually use the entire 8 cores, if you want to use the entire processing capability that your instance or machine has, you need to write something that can run in parallel, that can run the copies of this program in parallel. Okay, so let it complete. So it took 60 seconds. So 01 here, it means 1 minute. Okay, so now I will run the same program, but using a parallel. So how many CPUs do I have? Let's check. I have 8 CPUs. Okay, so 8 CPUs. So 60 divided by 8 is 5. So next time when I should run the loop in parallel, 60 divided by 8 is not 5. I'm in close to 7 and 8. So 7 or 8. Okay, so it should essentially take 7 to 8 seconds. Okay, so I'll just open the program. Okay, and I'll do live coding in front of you so that you understand how to read certain code, because in this we are calling this. So what I'll do is, to convert this program into parallel, what I'll do is from JobLib. So JobLib is the name of the library. Import parallel and delete. Parallel with a capital P and delete with a small d. Okay. And I'll say that instead of for loop, what I'll say is I'll create a parallel process in which I would create n jobs equal to -1, which means that my program can use all the cores that are present. You can specify 2 here, you can specify 3 here. So 3 means you are only giving 3 codes to the program. 4 means you are only giving 4 codes to the program. But -1 means that you are essentially allowing the program to use all the codes that are available in your CPU, for your CPU. And then what I do is I'll use delayed, and then the name of the function that I want to use as delayed. So test fun, as we want to call it, and I want to give index and sleep duration, which is 1 here. Okay, and I want to do this for all the index DM range 60. Okay, so I'll comment out this code. Basically, I have converted a for loop into a parallel for loop, which means that the copies of this program will run on different cores, and essentially we will get the same result in less amount of time. The syntax is a bit tricky here. I mean, you'll get the syntax by practice, but the syntax is really simple. You create a parallel object, you tell what are the number of jobs it can take, and then you put delayed in front of the function which you want to delay, which you want to run in parallel, and then in another brackets you can pass the arguments that you want, and you have the same for loop here which you had previously. Okay, so I'll escape. Now I'll run the same program. Let's check whether it happens in 8 seconds or not. 32, 40, 48, 60, bam. In 6 seconds, now we are able to complete because we had used all the cores of the program. Okay. Earlier we took same program took 1 minute to run because it was running on a single program, but now with the presence of 8 processors, we are able to scale it. So you can check, 1 second per iteration. Here it is 9 iterations per second. Okay, so the units also have changed. So this is how you parallelize your code on the CPU, right? And use the CPU processing power to the maximum. You open any of our scripts and all of the scripts are written in parallel. Okay, so if you get this type of syntax, please don't be scared. This is exactly the same for loop that is happening here. The only thing different here is we are trying to run the same program in parallel on multiple CPUs. Won't the CPU need some core usage if we assign all? See, 100% of CPU is never getting used by a Python program. It is only a percentage, maybe 2%, 3%, or 4% of a particular CPU that is getting used. Okay, so it's never that your Python program will capture 100% of the CPU. It can happen. It has happened with us in some of the core cases, but essentially everything works fine. Even if you run another program of Python, it also runs without any fault.
Hello.
Okay. Yes.
Like here you have used all the cores in this parallel programming. So can we use, like, if we have 8 cores and we want to use 6 cores out of that for this program, can we do that also?
Yes, I'll go back again and I'll run the same thing. Instead of -1, what I'll say, I'm saying is I'll give only 4 cores. Okay,
Okay, okay.
I have a total of 8 cores and I'll give only 4 cores. So now essentially the time taken should be get doubled. Okay, let's see. Earlier it took 6 seconds. Now if you're given 4 cores, it will take around 12 seconds. 13, 14. Okay, so this is how you can limit the core usage. Right? The speed has halved. If you check, earlier it was 9.54, now it is 4.20. Similarly, if you do it 2, then it would take more time. 21 seconds. Okay, I'm cutting down. If you do 1, that essentially means that you're running the program on a single CPU, which means it will take 60 seconds to run. 60 seconds. Okay. This is how you do parallel programming using your CPU power that you always have, but you're never aware of that you have. Okay, and this is a very powerful tool. If you can go to tonight or maybe tomorrow and just look at the syntax and how this works, then it would be beneficial for you in the long run. Okay. Okay, so now we all agreed that we need to clean data. Okay, so we all agreed that there is a need of removing the foreign characters because those cannot come if we are going to create an ASR for Hindi. So what do? We have a cleaning script. So we just go and execute. I'll just first execute the script and then we'll talk about what the script does. Okay. And okay, so I have to find where the script is. Okay, so here it is. So I'll just do a cat of the script. Cat clean Hindi. It's a big Python script, which I think we would be seeing that, oh, another Python script, and how would we understand and all and all. But nothing here is very complicated. It's very simple programming. Yeah, let's start from the main folder. So you provide an input folder and you provide an output folder. So you can ignore the symlink as of now. Maybe at a later stage, I'll tell you what is symlink. But what you are doing is, here is a parallel processing. So you are calling the function process text file for every fpath in TQDM text file list. So essentially you are getting a file list from the text file list. Where is this function defined? Here is this function defined. So glob is something from where you can actually find all the text files in a particular directory. So you get all the text files from this directory and you run a for loop on every file and you run this function called process text file. So in process text file, let's go step by step what is happening. Okay, so the first step that is happening is reading of text file. Every text file resides on as a single text file, but how does Python knows that that file is there? How to bring that file here? So you have to read the text file. So to read the text file, there is a function called read text file, which opens the file and returns the lines that are there in the file. Okay, and then the function, and then once the sentence has been read from the file, you execute get clean lines and you pass on the sentence and a pattern. Okay, so pattern is something which is defined by us because we know the vocabulary of Hindi. We know that there are 63 characters in Hindi and anything coming apart from that is not a Hindi character. Okay, and for that we have defined a regular expression that I'll just show you because it's difficult to show it on the terminal. Maybe I'll open a file in the local and show you what is that pattern. So essentially you pass the sentence and the pattern to get clean lines function. So what it does, it's the first step it does is strips. So strips means removing any white space present at the front or the end of the text file. So white space as in space characters or maybe tab characters, we don't want that. Okay, and the second thing that happens is you replace special characters. So these are special characters. So special characters can never be spoken. Okay, so suppose like something like dot can never be spoken. Something like comma can never be spoken. Of course, plus minus division can be spoken, but here we are considering them as a special characters. So we are saying that essentially we will remove, we will substitute. So RE is a regular expression. So we're saying that we will substitute special characters with empty string. Okay, which means essentially we are substituting special characters for nothing. Okay, and then after doing this, we are saying we are normalizing the text.
Are you introducing space there or nothing?
No, we are not introducing space here. You can check, there is no space in between. It's just empty screen. Okay. So once this is done, we do normalization of the text. Okay. So we use a special library for normalizing. This library has been written by Anoop, who is a researcher in Microsoft, which is known as Indic NLP library. Even the links for this is present in this MD file. You can open. So this is written by Anoop Kuchakuttan, and he's a part of AI for Bharat. We also work with him, and AI for Bharat is an initiative. I think a lot of IIT Madras professors are there in AI for Bharat initiative. So this is a library that has been written by Anoop Kuchakuttan, and what is present in this library? Text normalization, script normalization, word tokenization, word segmentation, all the stuff for all the Indic languages. Okay, for most of the Indic languages. Okay, so if you want to do a normalization for Hindi, then we are not writing any custom code. We are utilizing the library that has been written by Anoop in our script. So basically, this is the function in which we create an object of normalizer, and after normalizing, we are returning the process sentence. So what does normalization means? I mean, normalization can mean a lot of things, but what does normalization means in this context? So there is something known as let me open because it's a bit hard to explain. So there is something known as Unicode normalization. Okay, and there are certain terms like just a second, NFC and NFD normalization. Okay, so what essentially it means is that suppose this S exists as a single character in the vocabulary. Okay, but this S can also be written as a decomposition of only S, then a dot at the bottom and a dot at the top. Okay, so this S can be written as a decomposition of 3 characters, which is known as NFD, Unicode normalization. Okay, normalization form KD or normalization form D. What in our models we use is NFD. Okay, so we are saying that if there is a curve with a bindi, then that curve with the bindi is not a single character. That curve with the bindi is a combination of curve and bindi separate. Okay, right here S is written, right? S bindi and bindi is there. I mean, at the top, at the bottom is there. So there can be two forms. Either this S exists as a single character in a vocabulary. Okay, in that case, in your final dictionary, the dictionary that you will pass it on to your fine-tuning model, you need to have this S in that dictionary. Okay, but if you want to avoid these characters, because these can be in less frequency, so if you want to avoid, you can say that instead of NFC, we will follow the NFT, in which S will be separate, the bindi at the bottom will be separate, and dot will be separate. Okay, so instead of a single character S in the dictionary, three different characters will be present in the dictionary, and we will ask the model to predict this S as a combination of three different characters. Okay, I know, I mean, it is a bit tidy concept, but the point here is that a curve with the bindi on the left, I'll show you. How do I show you? Translate. I'll Hindi. Now see. I'll zoom the window. Now, kagaj. So there is a bindi at the bottom of j. Right? Now, what you can do is you have two choices. Either okay, I'll just copy this word and here is the terminal. Python. Okay, so now you have an option that this kagaj can be written as k separate, a separate, g separate, and a j with a bindi separate. Okay, so this is one option. So in your dictionary, which you will pass to the model, and which you'll say that these are the characters that you have to predict, this j will be independent character, this g will be independent character, a will be independent character, and k will be independent character. Okay, but you have another option in which you normalize the text and you say that this j is not an independent character. This j is a combination of dot and j separate. Okay, let me try to run the code. I mean, let me try and run the code so we can get a hands-on working of this example. Okay, just give me a second. Utils. Instead of send, I'll put same word kagaj, copy the same word kagaj. See the difference. Earlier, it was saying K is a single character, A is a single character, G is a single character, and a J with a bindi is a single character. Now, after normalizing, see what has happened. Is saying a K is a single character, A is a single character, G is a single character. This J and a dot is a combination of J, and this is called halant. Okay, I don't know halant or not, but yes, I think this is called halant. Right? So it has decomposed J with a bindi into two different characters. Now, if you are passing a dictionary to the to your fine-tuned model, you have to tell the model that you have to predict K, A, G, J, and a halant as well. Okay. Earlier it was J with a bindi. Okay, there was no halant. But in Hindi, a halant can come with the multiple characters. It can come with a K, G, Y, right? So you cannot have an individual character for every K, K, Y with the halant. Okay. So what you're saying is halant is separate and it can come essentially with any character. Like this A can come with any character. It can come with G to become Ga. It can come with J to become Ja. Right? So this halant can come as an independent character with any of the characters. So this is basically what the normalization does, and this is what is known as NFT normalization, where you decompose a single character, which can be a composition of 2 or 3 different characters, so that you get canonical form. Canonical form is the least canonical form, in which you cannot separate J and halant further more than this. Okay.
So every transcription, either we can just represent using NFD or NFC.
Yes.
Is it?
Yes.
So okay.
So your
what is
scheme has to be consistent for your data. Either it is NFC or it is NFD.
Mm-hmm.
It cannot be mix of both. If it
Correct.
is a mix of both, your model will actually get confused.
Mm-hmm.
Like whether to predict halant or whether to predict the J with the bindi, right?
So usually we'll have NFC way of
Yes.
writing.
So when you, in most of the cases, what we have seen is a NFC normalization, but we convert to NFD.
Okay. Okay. Any specific advantage like when we do so? Say to NFD format. Like,
okay, I'll show you. Maybe this example will clear everything. Okay. So these are a fine-tuned models. So when we fine-tune, we also provide the dictionary to people so that they know what a model can predict. Okay, so I'll open a dict from the newer model that we have trained, and I'll open a dict from the older model that we have trained. So this is V1, which is not depreciated. We do not recommend usage of these models. We recommend usage of V2 models. Okay. So what essentially is the actually dictionary in the browser, it doesn't comes like this. So I'll just save it to my local and we'll open in VS Code. Oh, it's old. And so this is a newer dictionary, okay, which has 63 characters, okay, for Hindi, okay, and I'll just zoom. How to zoom in VS Code? How do you zoom in VS Code?
You can do Control plus, Arvind. Control plus.
Okay. Not even this much zoom. Okay. So we have 63 characters in our current dict, which means that a model can predict only 63 characters, and you check halant here. Halant is a separate character, okay? But otherwise, in our old models, if you check, there were numbering as well in our old model. And in that old model, we had K, K, G, J, D, F, per year.
You need more characters. Okay.
Yes. But now we are saying that instead of having these characters, we'll have cur as it is. Cur as it is. There is cur. Cur as it is. And halant as a separate character. So a halant can decide whether it wants to come with a cur, khur, gur, any character.
Yeah.
But
So
here we were
you get it in NFT,
That is-
then later you convert to NFC, right? For our reading purpose. I mean.
Yes, so this was on NFC. This dictionary was on NFC, where we were using the characters as it is, but this dictionary is on NFT, where we are decomposing the characters into their lowest canonical form. Okay, because halant is separate here and there is no curve with the bindi in the newer models. Now the advantage, you check the advantage. Earlier we were predicting 80 characters. Our model was predicting 80 characters. Okay, you can remove 0 to 9 because 0 to 9 is not there in the new characters. So we were predicting 70 characters, but now we are just predicting 63 characters.
Okay, accuracy goes up?
Goes higher.
Yeah.
Because your number of classes is getting reduced and data is essentially the same. Okay, because you have reduced the number of classes in which you want to classify. Because if you check here, okay, halant is not there in this text, but the occurrences of ka, kha, ga in the text is very low. Okay, a ka with a bindi is very low. The occurrences of ka with the bindi is very low, but here the occurrences of ka separate and a halant separate are very wide in number. Okay, so they are present in huge quantities, hence our model benefits from that if we are able to reduce the classes. Okay, so that is why here we are using NFT normalization. So we are decomposing a particular Hindi characters into its lowest canonical form.
And what are these numbers in front of character?
So this is the frequency of characters in the training set.
Okay.
Here it was random. Here it was 1, 2, 3, 4 for every set. But in the newer dictionary, these numbers are the frequency. Like ka has come like 1, 2, 3, 4, 5, 87 lakh times, 8.7 million times. So ka has come 8.7 million times. A da with a bindi at the side had come only for 56 times.
Okay.
Right?
So that you are using in dictionary?
No,
that information. Yeah, that information is not needed, no?
That information is not needed, but it's good to have.
Yeah.
But this class imbalance can have some effect on the accuracy.
Yes, it can have some effect in predicting this because it is less in number. Right?
Yeah.
But for other, it is quite okay. I mean, see, if you pick any paragraph on internet on Hindi, you will find numbers in the same ratio. You'll find, the occurrence of characters in the same ratio as you're seeing here. Okay, so whatever we are seeing in the real world, it is expected. A cur is expected to come maximum number of times in that paragraph. You just pick it and just analyze if you want to analyze, right? So that is how it is. And see this a ki matra, it has come like 10 million times, I think. 1, 2, 3, 4, 5, 6, 7, yes, 10 million times, right? So this is what happens. Even if you take a normal distribution, some characters come very frequently, some characters come less frequently, right? But yes, there will be some accuracy loss in terms of predicting this character because the occurrences of this character are very low. Okay.
Yeah. Correct. So, is there a way to deal with the play with the softmax? If that is the last activation function.
Yes. So, actually, there is not softmax in the last activation. There is CTC loss, as we discussed, right? Softmax is not present, but they do have weighted CTC. In which they give less weights to the less frequent character.
No, other way around, right? Higher weightage to the less.
Yes, higher weightage to the less frequent characters. But that is also experimental at the moment. That is not present in the current code that we will run. They are trying out something with less frequent characters.
Yeah.
Right. So this is the concept of NFC and NFT normalization. Now, of course, this is a very
one more question.
Yeah.
Actually, in Hindi, we use some half characters also while representing a word, say.
Yes.
So, is it required to represent in the dictionary also the half characters like swad, half of saw and wo? It is written combiningly.
No.
It's not required.
No, it is not required. I tell you why. Because whenever that half character comes, okay, there is a character. There is a reason for that half character. Okay, so you give me a word for that half character. I mean,
say swad. Saw, half of saw and wo. Swad.
This one, right?
Yeah, this one. Half of saw and yeah.
Okay. Wait. I'll open the terminal and I'll check it is composed of which characters. Okay.
3 characters: saw, halant, and wo.
Yes. Now you check sir as being on a character level. Sir is complete, right?
Yeah.
But when it is displayed on the terminal, it reduces to half because va is present afterwards, and there is a halant here, right?
Yeah.
So that is a property of a character combining with other characters.
Okay.
We do not need to mention that in dictionary.
Okay.
We want our model to learn that on its own.
Okay.
So even if you check our portal, I mean, if you go to our portal and check how these things are there, you check the same exact behavior that you are seeing now. Okay, so like swad. See, it started with the complete sir, okay, but when it saw ver and are, it became half sir, and there is no half sir in a dictionary. If you check, there is no half sir in a dictionary. Okay, and similarly for other half characters that come.
Okay.
Okay, so I think this was a very trickier concept which is not known to many. See, if you go to industry and ask industry practitioners what is NFC decomposition, NFT decomposition, 9 out of 10 people won't be able to tell you. Okay, it's a very uncommon concept, but this is something that we also made a mistake when we trained our first model.
One doubt.
Yes.
Sir, in SWAT, sir.
Yeah.
So your like the model which X step was done. So it first predicted sir, complete sir.
Yes.
So after the complete swad was spelled out, it was giving half sir.
Yes.
So first when complete sir was there, it was due to phoneme, and when last half sir came, it is due to language model or also.
See, it can be due to language model. I'm not denying the fact, but half sirs are also an output of an ASR as well, from our ASR model as well. Okay, so we can confirm that maybe tomorrow, day after tomorrow. But the point here is it tries to predict first on each character level. Okay, so first you will see characters like sir, ver, are, and the, and then it combines them together to form a one word. When it combines them together to form one word, then it has information that if these letters are combined, then the word will get halved. The sir will get halved.
Okay, so then there is no need of your language model.
Yes, language model can also be present, but not especially for this task, for converting a full sir to a half sir. That is not the task of language model. Language model task is to display misspelled words, okay, which are maybe wrongly interpreted by a model or anything else, but not this task.
Okay, sir. Okay, thank you, sir.
So you mean to say half sa is also part of the dictionary?
No, it is not part of the dictionary. As I said, I mean, if you check a dictionary, half sir is not a part of dictionary.
But how did it derive the thing?
Because it knows, see, in a transformer, the network has a transformer, right? And the transformer has sequence self-attention layers, whose work is to learn the sequence information, right? And in that sequence information, it understands that if these two words combine, then that the previous word has to get halved.
Excellent.
Right?
Okay.
So that is the beauty of the transformer, and
Yeah.
when you are doing a label task afterwards, right?
Yeah.
And there can be multiple representations to half characters as well. Okay, so this was one representation which you saw, half sir. Then half can also be written as like this, sir, and there is a what do you say, tilted sign at the bottom, if you are able to see here, right? So this can also be one of the interpretation. Okay, but since in our normalization takes care of this thing as well, it converts half of this to the full characters, and basically then the combination of characters understand that this previous character has to be halved.
Yeah, so especially these things are very helpful because see, this learning doesn't happen by the feeding of the labels. I mean, so in that sense, dialect is naturally taken care if the data has in it. Like,
Yes. So direct is taken care of. So, but the point here is that how does a half sir, I mean, if you have to check how does a half sir is represented in a text, okay, but after we have normalized. So you check, there is a, I don't know what this thing is called, but
this is called halant actually. Halant is the use of joiner between two consonants can be joined together using a halant.
but
That
halant is a dot, right? It's not
no,
a,
no, no, no. To correct you, the previous symbol that you told, that is called actually a nukta. Nukta.
nukta, sorry, yes.
Nukta.
Yes.
Okay. Nukta can be put in the top of the character or bottom of the character.
Yes, yes.
And this is a halant, and it is the joiner for many of the languages like Assamese,
Yes.
Bengali, Hindi, Odia.
Yes.
This is used as joiner between two consonants.
Yes, yes, absolutely. So the previous example that we took here, j and j, so this is a nukta. This is a nukta, which is a dot. Okay, dot can come either at the bottom or at the top, right? And this, what we are saying is, instead of half sir or any other information, what we are saying is we put a halant. So it is a combination of halant. So if you check our dictionary, you will find halant. So you will find. So this is
at the end, I think.
Yes. So this is nukta. This is nukta, and this is
last one. Yeah.
This is halant. Okay. So this means how it takes care of half characters is the fact that when a sir is followed by a halant, it knows that it has to predict the half character, and this is how the interpretation either on a browser is done. It can also, as in case of this character, when I pasted this, it can also come at the bottom, or it can not come in the bottom and represent half sir and vada.
Also, Arvind, one more doubt. Say, if you say like 10 minutes data, right? So in those 10 minutes, like it may not have seen all such half words and half character and such things.
Yes.
So still it will be able to manage. What do you think?
See, we have tested a minimum on 10 hours. Okay, and in we have made sure that in those 10 hours, all of these 63 characters are present.
Okay.
Okay, and in a similar ratio. I mean, I told in a similar ratio, like this is out of 4200 hours, what I am showing you. Okay, but we have essentially said that in the same ratio, those are present in that there as well. If that are present, then the model will be able to learn from that. But if there are some characters which are very low in frequency, then there is a problem.
Yeah.
Right? So this is a nukta and this is a halant. Okay, so by mad. So this is a nukta and this is a halant. Okay, and yes, this is present in many other languages as well. Of course, I just know about Hindi, but
it is present in Odia, Bengali, Assamese. Actually,
No,
this
even we have Swada in Kannada. After all,
Okay.
Sanskrit is the derivative, right?
Okay.
We'll have all those things in
Okay.
Kannada also.
Okay. It is basically used to join two consonants.
Okay.
When we have a compound characters, we have in Odia we have compound characters. When we join two consonants, like say spurs. In spurs, saw and paw joined. So
Okay.
half of saw and paw. And in Odia we write saw fast, and at the bottom of saw paw is written. Spurs.
Okay.
I think these are all something related to orthography, I think written system of a language.
Yes, absolutely.
Yes.
So different, I mean, in different browsers, you might see different output as well. In
Yes.
some browsers, you may see a sir with the halant at the bottom, and in some browsers, you'll see a half sir.
Correct.
Yes, so that also plays a lot of role, UTF-8 encoding or not. So yes, that is also there. So I think we have covered most of the things that I wanted to cover in this session. Of course, I wanted to prepare the data for fine tuning and clean the data, but I think we can do it tomorrow morning, because tomorrow in the first half we will be doing a practical session, and maybe in the second half we'll go back to a little bit of theory on the LM side. Why in the first half practical session? Because the model training would take a bit of time to execute. I mean, it would take like 3 or 4 hours for the model to converge. Okay, and for your learning, I think it is better if we start training the model in the morning tomorrow. Okay, but if everything if everything up to now is clear to you, then it is perfectly fine. The next step is we just need to execute this screening script. Okay, so we need to execute this screening script so that we have data that is screened of all those symbols. Okay, we were discussing about the screening script. Just give me a second. That's it. So here, normalize and token after you're done, then your NFC and NFT normalization is taken care. By default in Indic NLP library, NFT decomposition happens by default, but you can change it to NFC decomposition as well. Okay, so when I was analyzing this data set, I found out that these are the foreign words like LS, cuff, sniff, beat, bang, VN, SIL, horn, burp, TC, laugh, HR, LNV. So what I did was I just write a script like for word in foreign words, line is equal to line dot replace the word with nothing. So wherever there is a cell or something, it is being replaced by nothing. Okay, and so this was the cleaning that is being done. The first step is stripping out the excessive white space that is maybe present on the left or right side. Second step was cleaning the special characters. The third step was normalization and tokenization. Here the NFT normalization takes place through Indic NLP library. The fourth step was to remove the foreign words like Silberg, Bank with nothing. And even after all these things, even after all these steps, if there is something that appears in the particular file that should not be present, then what we say is we remove that particular file and the corresponding audio file. So this is what we are saying, that even after doing all these steps, there is some foreign character in a particular transcript, then we remove the audio and the transcript altogether from our training data. Okay.
Yeah, for some transcriptions that say BN, cough, all that might be necessary. Say especially movie, right? When it gets translated to our languages, so are people who are not able to listen to, for them, like this kind of transcriptions also might be a necessity in the.
Yes. So you can. So what you can do is, instead of cough, hum, sniff, and all, you can map them to numbers. So maybe 0 represents cough, okay, and then wherever there is cough, you can replace cough with a number in the transcript, right? And in the post processing, whenever you are getting 0, it means that there is cough in that particular part, and then you can predict the cough as well.
Yeah.
Right.
True.
But here our motive is to just have a clean transcript and to get a clean output. We don't want curve, SIL, beat, bang. But if you have some custom use case, yes, you can do anything with that. Right? So, okay. So what I'll do is, we run the cleaning script on the training data. Okay, so the command is present in front of you. I'll just execute the command and I'll tell you what is the input and output. As I already told, input is the input folder and output is the output directory where you want to keep your processed data. Okay, so I'll just open this. I'll clear everything, do ls again. So I want to run in Hindi, and my input is present in the data folder, which is 3 times back, I think. Raw folder, then train folder. So you just have to give the train, okay, and where you want your output to be. I want my output to be present in the same data folder, data, inside processed, inside train. Okay. So I'll basically, if you go to this path, I'll just ping you entire. So these are the commands. If you press enter now, you'll see a progress bar, which is now cleaning your transcripts and is also copying your WAV files to a new location called processed. So since there were only 27,131 text files, so this cleaning script has run only on that particular data, and it is showing that duration rejected is 0 hours. So none of the data has been rejected due to presence of any foreign character. Okay, so let's go and check what is the new data. So if I go to data folder, you now see 2 folders. One raw was something that you downloaded, and now processed. If you go to processed, go to train, and then I'll ls for the top 10. Go to train, and then I ls for the top 10 entries. So these are the top 10 entries. So your WAV file is the same file that was present in the raw text. It is exactly the same copy of that file, and the text file is your new file in which your transcripts are now cleaned from all the symbols that were present in the training data. Okay, so let me show you. So you do a cat. Now there is no cell, there is no bn inside the text. You may open any file you want. Yes, no cell, no text. No cell, no text. So if you have executed this command, now our data is ready to get trained. Okay, now we are ready to start training our model. Okay, so the difficult part has gone. Understanding the data, understanding NFC, normalization, understanding everything, that has gone. Now your data is ready to get started for training. Okay, so please execute this command and let me know if you're finding some difficulty and all. Please mention steps after Python with WEC duration. So that was to find the duration. Now what we are saying is we run the cleaning script, and to run the script, please follow the commands. Please follow these commands. Go to Vakyansh utils data folder and please run python clean.py -i, which stands for input, which is your input directory, and -o stands for the output directory. For people who have done, I would recommend you to check the text files by going into the processed train folder and check if there is any SIL or hum or BN or any kind of foreign characters present apart from Hindi. Nobody who named Indic NLP. I am not sure why you are not why you are getting this error, because Indic NLP is in the requirements file. But if you're getting this, then please execute this command. Please make sure you are inside the FairSec environment. Okay, that is required. Okay, so at any point of time, see, you need to have FairSec on the left side of your name. Yes.
Yes. One thing. Okay. See, in the fine-tuning aspect, so the limitation is 15 seconds should be our audio file, right?
Yes. Yes.
That's required because of the text alignment problem, or
no? That is due to the fact that a GPU can process a maximum of 15 seconds at a given point of time.
And how does the text and audio alignment is taken care while training? Or
so that happens using a CTC loss, right? So for every 20 milliseconds there is a prediction, and in that prediction, using the CTC loss, the target is checked whether the target whether it is able to predict something or not. So if suppose in the first 5 seconds of audio you have silence, so nothing will get predicted for those 5 seconds. Okay, and only just when you speak and there is some particular representation of that audio present in the pre-trained model that you just took, then only that representation would be mapped to a particular character that would be present in the fine-tuning dict.
Right. Okay. So if I have a very lengthy file, right, say half an hour or so, when I do break up that file into 15 seconds chunk, so then I may lose up the text alignment part. So I should have a aligned text firstly.
Yes, absolutely. You need to have subtitles. So subtitles have durations within and the text within that duration.
So how do you people manage to generate that aligned text in case of, like, if you've downloaded the data from, if you get the Google text as an output?
Yes. So in the morning I showed, right, if we have a 30 minutes long audio, we would split that audio into chunks using voice activity detection, right? And then once we have the segments, we run an SNR on the segment. And after running SNR, we would run the Google STT on that particular segment.
Right? So STT itself gives a text alignment timestamps, is it? Yeah.
Yeah. So when you are running on the segment, so segment is already
chunked. Okay. You run the okay. Yeah, got it. Yeah, fine. Yeah. Thank you.
I think as long as we are not breaking the words, it is fine. Even phrase level also can be splitted, I think. As long as it is not middle of the word, it is fine, I believe.
That's exactly right, sir. So we break it using a voice activity detection.
Voice activity detection. Only
Yes.
silence regions.
Yeah. Just to add one more thing, so we tried to basically pass the whole half an hour file using Google speech to text also. They give some timestamps, but those timestamps were not very accurate, and the words were basically cut at the ends. So that's why we decided to basically go to WAD first, and we could not lose words at the end, and then run the transcript.
Okay, yeah.
So YouTube, maybe whatever your recordings you have downloaded, that may also contain some music. No, how you handle that part?
Yeah. So if there is noise in the background, that's actually good for the model, right? Because that makes the model more robust. The question here is that is the Google speech to text good enough to work in musical conditions, right? So if the transcript is basically the same as what was spoken in the audio, even there is anything else in the background, it doesn't matter for us, because we want our model to be more robust in all the conditions.
And also, sir, like in the transcript, we have removed the silence regions and the burp sounds and bounce sounds and all. So, but we are not doing anything to the audio file. So
Yes.
there will be misalignment of the transcript to the audio. So how do we look into that?
No, I mean, why do you think there would be misalignment?
Because we are removing the silence in the transcript.
Yeah, we are removing the silence in the transcript, but we are doing nothing with the audio, right? So whenever there is a silence in the audio, nothing is going to get predicted.
Okay.
Then how would the line come here?
Basically,
Arvind, the problem is so output should be one of those classes, right, in the dictionary. Yeah.
Yes.
Because silence is not part of the dictionary.
So this is a dict that is shown to you. Silence is surely a part of dictionary.
Okay.
It is internal dictionary. So whatever characters you have, there are 4 characters apart from that are special characters that are added to dictionary. Okay. So one of them is an underscore. One of them is a horizontal bar, and one of them is a space. Okay, so these 3 and one of them is unknown, UNK.
Yeah.
So these 4 characters are added by the FairSec library to your dict. So if you are predicting for 68, if you have 63 characters in your dictionary, the final dict would have 67.
Yeah.
And in the final layer in the neural network would have 67 outputs, not 63. Okay? So we don't need to care about the alignment. See, alignment part, we have to rely on CTC for that.
Yeah.
There is a
It
reason
would have
why.
learned the character mapping and waveform, basically. Yeah, it would have learned the waveform representation. Not the waveform, it's a latent whatever that.
Yes.
Yeah, essentially, all the background noise, music, silence, everything gets mapped to one symbol called silence and we ignore.
Yes, you can do that. We can do that. So that whenever there is something, we just display it that, or maybe this is silence, or maybe this is noise, or something like that. We can do that. We can do that, but we don't want to do it.
I was just addressing Ayush's statement that even if there is no background noise label, it will be treated as part of the music background. Sorry, silence itself. Yes.
Yes.
No, nothing is needed. Thank you.
Absolutely. So, is anyone facing any issue up till now? And if not, have you checked the process train folder? I mean, for people who have done. Because if you have done this, then your data is now ready for training. Okay. So tomorrow, the first thing that we will do is training.
Okay, so we have done the cleaning process with the text files.
Yes.
But what if there will be something in the audio files, like the size or the sampling rate is different? So then,
yes.
What we need to do?
So for that, you need to write a script for audio files, like we have written for text files. So similarly, you can write for audio, which can actually bring the audio from a higher sample rate to a lower sample rate. Within the same script, you can write because what we are saying is in the processed folder, we have a data that is processed. So in this experiment, we are just processing the text files. But of course, if there are some problems with the audio file, we can process that as well. So I'm not showcasing that at the moment because working with SOX is a little bit tricky and it takes a little bit more time. Processing of audio takes a little bit more time than text.
Definitely, because see, if the size will be different, then we have to change the text file content also.
Yes.
Means if we certain the size of the video or audio,
Yes.
then we have to change the corresponding text file also.
Yes. So when you train your model, so there is an option that for just for the size, I can tell you. So you can provide a maximum size at the time of training. Okay. So the maximum size is dependent on your GPU or how big GPU you have. Okay. So once you define the maximum size that and you can also define that any file that is greater than this size should be avoided or deleted or should not be skipped or should be skipped from the training set. So that is taken care in the model training itself. If you're just talking about the size, but for the sample rate and all, you need to have custom scripts like we just cleaned the text. We have
That can be done. But how to know that how much size is allowed in a GPU? Is it fixed or it is variable?
No, it is a hit and trial method basically.
Okay, hit and trial method.
So you keep on reducing your tokens until the size you get a token on which you do not get a CUDA out of memory error.
Okay.
We'll talk about this tomorrow, like how to determine the size and how does the calculations take place. There is a bunch of maths on that. But again, I mean, there is no deterministic answer to any question. It is pure hit and trial.
And one more thing, that the way you have told today and we executed and we can understand the things better way. So similarly, if it can be done that taken a 1 minute video, how can we use actually this BAD and all these things to make these training files like this audio files and the transcript files? If we can do at our end also, just a sample, then it would be better. Means we will be benefited.
I'm not sure. Is that something that was not covered in the previous week by Rajat?
No, that is covered, but actually means in a what exactly I am telling is just to, I don't get a feel of doing that as I get the feel of doing the things today. That suppose given a 1 minute video, so how can we segment into say 15-second videos? Sorry, audio, and how can we make the transcription files and of this, so that we can make locally we can make a training set or testing set or something like that. Okay. So that feeling.
Okay, so you don't want to run the pipeline, but you're saying
Yeah, without using the pipeline and cloud. So if we can do, so that we'll get a feeling. I think many of us will get benefited.
Okay. Okay, let me see today what I can do. Okay, maybe I can devise a small tutorial, but I would be able to cover that by day after tomorrow only. Okay.
No issue, any day, no issue. So just to get a feel of that, how.
Yeah, don't worry. I'll do my best to cover a tutorial in which you have a 30-minute long audio and you will be able to break it into chunks. Pass through SNR and then pass through Google.
Exactly.
I'll do something on that. No issues.
Thank you so much, Arvind. It's been a long day for you and as well as participants, but everything went well. It was a nice way of explaining things. Hope this has helped participants a long way to build the ASRs in Indic language.
Yes.
Thank you, Arvind. Thank you so much.
Hello, Arvind sir.
Yes.
Sir, I am facing a issue. So after completing all the stage, what you mentioned, and so it's working fine for the fast text file. Then whenever I am going to put another 2 file, there is a problem. So can you tell me why it is happening?
Okay, we'll sit after everybody goes, right? So,
okay.
Yes, we'll sit on that. Yeah. So I think tomorrow we'll start with the model training, and that is also very interactive process, and you will understand the metrics, you will understand the process, and all of these things, right? So please be prepared tomorrow morning. We will do the first thing we'll do is training our ASR model. Okay.
Thank you. Thank you. Yeah.
Thank you, everyone.
So we'll meet tomorrow. Yeah.
Yeah.
Thank you, everyone. Thank you.